In every age, people believe they stand at the peak of history. We look back on our ancestors as primitive, fumbling through darkness until reason and technology finally brought light. We imagine progress as a straight road stretching endlessly forward, each discovery paving the way for the next, each generation standing taller on the shoulders of those before it. Yet beneath this comforting idea lies an unspoken question. What if the road of civilization is not straight at all? What if it bends, breaks, and begins again? Across continents and centuries, old stories whisper of worlds that ended long before ours began. The Greeks spoke of ages of gold, silver, and bronze, each falling into ruin before a new dawn. In the ancient valleys of Mesopotamia, a flood cleansed the earth so that humanity could start anew. In India, time itself is cyclical, measured in vast cosmic ages that rise and fall like breath. Even the myths of the Americas tell of suns that died and were reborn, worlds that turned to ash before the next light appeared. These stories, scattered and echoing across time, may be more than allegories. They might be cultural memories of resets, eras when everything known was lost, and the human story had to begin again from the dust. When we study archaeology and geology, we find a record that seems to stretch back in order. Stone tools, bronze blades, iron weapons, machines, and cities. The pattern appears linear, inevitable, but the earth does not preserve all things equally. Seas rise, mountains crumble, continents drift, entire landscapes vanish beneath layers of sediment and time. If there were civilizations before the one we know, the Earth itself may have swallowed their traces. The deep ocean is our oldest archive, yet most of it remains unexplored. The crust of the planet recycles itself every few 100 million years. What chance does a city have to survive that slow grinding of stone and sea? There is a strange humility in imagining that we might not be the first to build towers or harness energy. Science teaches us that life has endured unimaginable cycles of destruction and renewal. The end of the Permian Age wiped out nearly all species. The later impact that ended the age of dinosaurs reset the biosphere entirely. The younger Dryas cooling event 10 to 12,000 years ago nearly ended early human civilization before it truly began. Nature is not gentle with memory. Each time the planet resets itself, only fragments remain. Fossils, isotopes, patterns of ash in the rock. The possibility that something advanced once existed before us is not a claim of fantasy, but an invitation to curiosity. How would we even know? What would survive after 10 million years? Or 100 million? Would our metals decay, our data dissolve, our monuments turn to dust? If so, how certain can we be that the slate of history is truly blank before the dawn of our known civilizations? This book does not promise revelations of hidden empires or forbidden knowledge. It offers instead a disciplined investigation, a skeptical yet open-minded exploration of evidence, geology, myth, and the limits of human memory. The question is not whether Atlantis or any single lost city once stood, but whether the pattern of civilization itself might be cyclical. Could there have been earlier rises and falls, deeper than our written record, erased by nature's own hand? To find out, we must follow the trail of both myth and matter. We must listen to the stories that survived the floods and test them against the rocks that remember what we do not. We must examine how progress can vanish and how history might reset. Perhaps the greatest mystery is not what lies ahead of us, but what lies buried beneath. And so, we begin where most histories end, with the assumption that progress is eternal and the challenge to ask whether that assumption is true. From the moment we begin learning history, we are told a story that feels almost natural. Humanity, we are taught, began in darkness and ignorance, then slowly climbed toward reason, invention, and light. Stone gave way to bronze, bronze to iron, iron to industry, industry to electricity, and electricity to the digital world. It feels clean, rational, and inevitable, as if the entire species has been marching forward along a single road toward knowledge. Yet when we look closer, that road becomes far less certain. It is not a straight line of triumph. It is a fragile thread, frayed by war, climate, and forgetfulness, constantly at risk of breaking. We imagine the past as a ladder, each rung representing a new achievement. But ladders can fall. What if our climb is only one phase in a much longer cycle of rise and decline? The ancient philosophers did not see history as a march of progress, but as a wheel. Hesiod spoke of golden ages giving way to iron ages. The Hindus described time as vast cycles of creation and dissolution, each age ending with catastrophe before another began. The Maya and Aztec civilizations spoke of previous worlds destroyed by fire, flood, or wind, each reset giving birth to the next sun. These were not merely moral fables. They were attempts to describe a reality where memory itself is fragile, where civilizations can vanish and begin again as if nothing had ever been. Archaeology gives us comfort in continuity. It shows a gradual line from primitive tools to cities, from cave paintings to written language. But we rarely ask how much of that record has survived. Imagine every artifact of our civilization buried beneath the sea after 1,000 centuries. How much would remain recognizable? Our glass would erode, our metals would rust, our plastics would crumble to invisible dust. Even the most enduring monuments, the pyramids or Mount Rushmore, would be worn smooth by time, buried beneath wind-blown sands or glacial debris. In the grand scale of geological time, a few thousand years are barely the blink of an eye. The illusion of permanence is one of our oldest self-deceptions. The Earth itself is not a stable archive. It is a restless, moving planet that buries and remakes its surface every few 100 million years. Mountains rise and are ground down to plains. Oceans open and close. Continents drift apart, erasing coastlines that once existed. The story of our world is one of creation and erasure repeated endlessly. Every fossil, every layer of rock is a survivor from an almost infinite number of vanished landscapes. When we measure our own civilization against that timescale, the pride of progress begins to tremble. What we call history is only a sliver of deep time, a thin line scratched on the surface of a planet that has been alive for more than 4 billion years. Yet we cling to the idea of steady advancement because it flatters us. It tells us that we are special, that there is a single trajectory leading from ignorance to intelligence. It allows us to look back and judge, to believe that each past generation was less capable, less aware, less human than ourselves. This myth of linear progress is seductive because it gives meaning to struggle. It transforms random events into a story of destiny. But what if that story is an illusion born of selective survival? What if we see a line only because so much of the pattern has been erased? Myth and memory often hide truths in symbolic form. When we read of floods sent by gods, of fires from the sky, or of cities swallowed by the sea, we treat them as allegories. Yet modern geology shows that floods and fires truly have reset the Earth's surface many times. The end of the last ice age brought a sudden rise in sea levels that drowned entire regions where early humans lived. Could those lost coastal plains have held settlements or cultures whose remains are now buried under hundreds of meters of silt and salt water? If so, our story of uninterrupted progress would become a story of rediscovery, not invention. Our earliest records already begin in the middle of something. Writing appears suddenly in Sumer, Egypt, and the Indus Valley, without clear evidence of long developmental stages. Great structures like the megaliths of Göbekli Tepe or the pyramids of Giza seem to emerge with startling sophistication. Archaeologists explain this as rapid innovation within small societies. But the question lingers: how does a species leap from nomadic herding to precise astronomical architecture in what feels like an instant? Could there have been forgotten precursors, small civilizations erased by flood or famine, whose techniques were preserved only in fragments and memory? To doubt the myth of linear progress is not to embrace fantasy. It is to remember that knowledge itself can be lost. The fall of Rome erased vast libraries, and Europe required 1,000 years to relearn much of what Greece and Alexandria had once known. The burning of a few cities was enough to cast an entire continent into centuries of darkness. If such collapse can happen within recorded history, how much more could vanish when entire landscapes change or seas rise? The pattern of human achievement may be less like a staircase and more like the tide, each wave advancing, retreating, and returning again with traces of the last. We must then ask a deeper question. If civilizations can rise and fall within mere centuries, what would happen if a reset were total? If an event wiped away nearly all memory, leaving only stone and story? Would the survivors, generations later, remember that cities once glowed at night, or that machines once flew across the sky? Or would they rebuild from fragments, believing themselves the first to ever dream of such things? The myth of linear progress protects us from that thought. It insists that we are unique. Yet the evidence of nature, of myth, and of our own fragility suggest otherwise. The illusion of progress comforts us because it hides the truth that the world resets itself with ruthless indifference. Species vanish, empires crumble, seas rise and fall. History is not a single line drawn toward enlightenment, but a series of interrupted songs, each new verse beginning on the echoes of one forgotten before. And if our civilization is only the latest stanza in that eternal rhythm, then the question becomes not whether others came before, but how completely their traces were erased. If such a reset occurred, what kind of force could sweep the slate of history so clean? What event could erase nearly everything, leaving only myths of golden ages and floods to remind us of what once was? To seek that answer, we must look not at human wars or politics, but at nature itself. For the Earth has its own ways of pressing the reset button, and it has done so many times before. When we speak of progress, we often confuse the story of discovery with the story of memory. Discovery is the act of finding something new, but memory is the act of keeping what was found. A civilization may be brilliant at discovering, yet poor at remembering. The myth of linear advancement depends on uninterrupted memory, on a chain of inheritance that passes knowledge from one era to the next. But what if that chain is fragile? What if it has broken many times before? When the chain breaks, progress does not simply pause, it collapses backward into silence. Humanity begins again, not as a continuation, but as a rediscovery. Archaeologists sometimes describe prehistory as a fog with small islands of clarity. We can see certain sites, certain artifacts, but vast stretches between them remain invisible. The deeper we look, the more fragmentary the picture becomes. Stone tools and bones survive, but wood, textiles, and stories vanish. The further back we go, the more we are forced to infer an entire civilization from what could fit in a single museum case. This limitation tempts us to simplify. We imagine an unbroken ladder of progress because it is easier to understand than the possibility of vanished chapters. But the evidence, if read closely, does not guarantee continuity. It merely shows survival. Consider Göbekli Tepe, built roughly 11,600 years ago in what is now southern Turkey. Its massive carved pillars predate writing, agriculture, and the known cities of Mesopotamia by thousands of years. It appeared suddenly, as if the builders already possessed a deep understanding of geometry, engineering, and cosmic alignment. Then it was buried deliberately, hidden under tons of earth and forgotten. How could hunter-gatherers have produced something so advanced, and why did they conceal it? Perhaps it was a unique cultural leap, or perhaps it was the echo of knowledge preserved through catastrophe, passed down from a civilization erased by flood or ice. Mainstream science explains such sites through incremental development. It argues that innovation can arise suddenly from complex hunter-gatherer societies without requiring forgotten ancestors. That is true and plausible. Yet the strangeness remains. Civilization does not emerge evenly across the world. It appears in bursts, separated by long silences. The Fertile Crescent, the Nile Valley, the Indus Basin, and the Yellow River each show abrupt transitions from scattered villages to organized cities. To call that coincidence may be correct, but it is also unsatisfying. Why does the pattern of emergence resemble rediscovery more than invention? Myths of floods and lost worlds may hold a faint memory of real disasters. At the end of the last ice age, glaciers melted and sea levels rose more than 100 meters. Vast areas of coastal plains disappeared. If early settlements existed there, their remains now lie beneath the continental shelves, unreachable beneath mud and salt. Marine archaeologists have only begun to explore these drowned landscapes, finding traces of forests, stone tools, and ancient shorelines. Each discovery suggests that our map of early civilization is incomplete, distorted by the simple fact that most humans have always lived near the sea, and the sea has reclaimed their cities more than once. When we lose land, we lose context. Archaeological continuity depends on finding layers of habitation stacked through time, one above another. If the sea erases those layers, the illusion of a clean beginning appears. The oldest surviving evidence becomes the first, even if it was merely the last to escape destruction. This is how linear history can emerge from non-linear reality. Our timeline is not a record of all that happened, but of what managed to endure. Geologists speak of unconformities, gaps in the rock record where layers have been eroded away before new ones formed. Between those layers may lie millions of missing years. The same is true of human history. There are cultural unconformities, gaps between what we find and what must have existed to explain it. Each gap could represent 1,000 forgotten experiments in agriculture, architecture, or astronomy. Each could be the silent grave of a people who mastered something that did not survive them. When the survivors rebuild, they begin again, believing themselves the first. The myth of progress survives because it comforts. It tells us that the universe rewards intelligence and that our destiny is secure. But geology teaches a different lesson. The universe is indifferent. The planet has buried entire biospheres without hesitation. The Permian extinction erased almost all life. The later asteroid impact that ended the age of dinosaurs cleared space for mammals to evolve. These were resets on a planetary scale. If such events can erase species, why not civilizations? The same physical forces that shape continents could also erase memory. And yet, there is a peculiar arrogance in thinking we would know if such a thing had happened. We measure time in centuries, but the Earth measures in millions of years. Even a few tens of millennia can reduce metal to dust and monuments to shapeless stone. The great basalt statues of Easter Island have eroded in only a few centuries of wind and salt. What would remain after 50,000 years, or 1,000,000? The line between never existed and no longer visible is thinner than we like to admit. The more we learn about the fragility of evidence, the less certain our timeline becomes. Archaeology is a science of fragments. It can confirm what existed, but it cannot prove what did not. The absence of evidence is not evidence of absence when the record itself is fragile. To claim certainty about the deep past is to forget how easily the Earth rewrites itself. Perhaps that is why myths of cyclical time endure. They preserve the intuition that creation and destruction are not opposites but partners. Every culture that remembered catastrophe also remembered renewal. The world ends and then begins again. For modern minds, trained to believe in progress, that idea feels pessimistic. But in another sense, it is hopeful. If civilizations can be lost, they can also be reborn. Memory may die, but curiosity revives it. The impulse to build, to understand, to reach upward seems to return each time the ashes cool. The story of humanity may not be a ladder but a heartbeat. Rise, collapse, rise again. The pulse of civilization quickens with each recovery, echoing the same drive that brought our ancestors out of caves and into the stars. And if there truly were resets before ours, their legacy may not be found in stone or metal, but in the instinct that keeps us searching for meaning in the ruins. If the myth of linear progress is an illusion, then the truth might be something grander and far more humbling. History is not a line leading upward, but a spiral turning through time, repeating its patterns in ever-widening circles. To understand that spiral, we must follow it back, not just through written history, but through the layers of the Earth itself, where traces of forgotten worlds may still rest. To search for them, We must ask what kind of force could have erased them in the first place? What power could sweep continents clean of memory and leave only myths behind? The answer lies in the story of Catastrophe, in the natural reset buttons the planet has pressed again and again. The next chapter will follow those cataclysms, the ones that reshaped the world long before we appeared, and perhaps, once again, prepared it for our return. Humanity's belief in constant advancement is one of its greatest myths and one of its deepest comforts. We look at the past and see a world of superstition and struggle. We look at the present and see light and order, yet every age before us has felt the same. The Romans believed they had reached the summit of civilization. The scholars of the Abbasid Caliphate thought knowledge had reached its perfection. The Victorians saw the Industrial Age as the final triumph of reason. Each generation declares itself the culmination of progress, forgetting that history has a habit of humbling certainty. The myth of linear progress is not born of evidence but of pride. Progress, in truth, is not a law of nature. It is an anomaly, a brief and fragile arrangement of order rising out of chaos. Civilizations are engines of memory. They store information in buildings, books, and digital archives. But memory is vulnerable to entropy. Fire erases libraries. Flood erases cities. Time erases almost everything. If progress depends on memory, then the loss of memory means the loss of progress. Each collapse in history shows how easily the line of knowledge can snap. When Rome fell, its aqueducts crumbled, its roads decayed, and much of its science vanished into oblivion. What followed was not a continuation, but a partial rediscovery. The same pattern has repeated countless times. Modern humans are the first species to leave a planetary signature detectable from orbit. Our cities glow at night, our machines alter the atmosphere, our satellites encircle the globe. Yet if we disappeared tomorrow, how long would that glow remain? Within decades, streets would be overtaken by vegetation. Within centuries, steel would rust and glass would crumble. Within tens of thousands of years, only the stone foundations of our greatest monuments would endure, and even those would eventually erode. After a few million years, almost nothing would remain. The fossil record would show a brief anomaly of altered carbon levels, a thin layer of synthetic compounds, and then silence. A future intelligence arriving after that silence might never know we existed. If such erasure is possible for us, it must have been possible before us. The Earth has been home to complex life for hundreds of millions of years. During that time, continents have drowned, climates have burned, and entire species have come and gone. To assume that no other intelligent culture ever arose, even briefly, is not scientific certainty but a leap of faith. The geologics. The record is incomplete by nature. Plate tectonics recycle the crust, erasing almost all evidence older than 200 million years. Our certainty about pre-human history rests on a surface constantly being rewritten. Still, skepticism must be our compass. The absence of proof for ancient advanced civilizations does not mean they existed, only that we must be cautious about claiming final knowledge. The strength of science is not that it has all answers, but that it admits what it cannot yet know. What we can say with confidence is that the planet has undergone countless resets, each one capable of erasing even the grandest achievements. The question is not whether such events occurred, they did, but whether one might have happened after intelligent life had already begun to rise. The mind resists that idea because it threatens identity. We prefer to think of ourselves as the beginning, not the continuation. Yet there is humility in recognizing that we may be inheritors rather than pioneers. If others once walked this earth and vanished, their absence is a warning. It reminds us that nature is indifferent to intelligence. The same forces that nurture life also destroy it without hesitation. To see ourselves as part of that cycle is not defeatist, it is grounding. It reminds us that progress is not a guarantee, but a privilege. As we study the ancient world, we find layers of brilliance built upon layers of loss. Every invention, every philosophy, every monument stands on the edge of erasure. We measure time in centuries and call it long, but the planet measures in epochs. Against that scale, even the mightiest empire is a flicker. Perhaps the greatest illusion of linear progress is that it tricks us into believing we are moving forward, when in truth we may only be circling the same truths over and over, each time forgetting and rediscovering them anew. History, then, is not a straight road but a spiral staircase carved into mist. We climb believing we ascend, yet the path curves endlessly around a hidden center. The deeper we look, the more familiar the patterns become: creation, growth, collapse, and rebirth. The stories of golden ages and floods are not fantasies of the past. They are metaphors for a truth written in stone and sky. The world resets itself. The question is how complete each reset becomes, and how much of memory survives the storm. Our next step is to leave myth behind and examine the evidence of those resets, the physical scars in the rock, the ash layers, the sudden endings in the fossil record. For if history truly has been rewritten before, the handwriting of catastrophe should still be visible. The next chapter will follow those signatures, tracing the moments when nature itself turned the page and began again. The Earth does not move gently. Its surface drifts, fractures, and erupts in violence so vast that human comprehension falters before it. We live on a planet whose memory is written in fire and stone, and each chapter of that memory ends in destruction. Life has endured for billions of years, but not continuously. Again and again, the world has been wiped clean and remade. To understand whether civilization itself might have been reset once before, we must first understand how the planet resets life itself. The story begins deep in time, long before any human ancestor walked the Earth. Roughly 252 million years ago, a chain of volcanic eruptions tore open the crust in what is now Siberia. Lava covered an area larger than the continental United States, pouring for hundreds of thousands of years. The gases released from that inferno filled the atmosphere with carbon dioxide, raising temperatures by more than 10 degrees Celsius. Oceans acidified. Methane clathrates in the seafloor melted, amplifying the heat in a runaway feedback. In that inferno, more than 90% of species vanished. Coral reefs dissolved, forests burned to ash, and insects themselves, the most resilient of all creatures, nearly disappeared. Paleontologists call it the Great Dying. The planet took millions of years to recover. The end Permian extinction was a true reset, a moment when evolution itself had to begin again almost from scratch. 66 million years ago, another catastrophe struck. A rock the size of a small mountain fell from the sky and struck the Yucatan Peninsula at more than 20 kilometers per second. The energy released equaled billions of atomic bombs. The world burned in an instant. Dust and soot filled the stratosphere, blocking sunlight for years. Photosynthesis stopped. The age of dinosaurs ended almost overnight, clearing the stage for mammals, and eventually for us. The Earth's surface record of that event is thin, a thin grey layer, rich in iridium, an element rare on the surface but common in asteroids. Yet that layer is enough to mark the moment when an entire world ended. These are the grand scales of extinction, planetary, apocalyptic, beyond anything humans have yet endured. But catastrophe does not need to be global to end civilizations. Sometimes the planet strikes with precision, targeting regions where life has become complex and fragile. The Younger Dryas, beginning roughly 12,800 years ago, was one such event. It came at the end of the last ice age, just as humans were spreading agriculture across the Near East. The world had been warming steadily, and then suddenly, within a single generation, temperatures plunged by several degrees. Glaciers advanced again, rainfall patterns shifted, and ecosystems collapsed. The cause is still debated: a burst of meltwater disrupting ocean currents, a comet impact, or volcanic activity. Whatever its origin, it brought centuries of cold and drought. For the hunter-gatherers of that age, it was a cataclysm that erased entire ways of life. In each of these events, the same pattern appears: abundance followed by sudden collapse, stability replaced by chaos. Nature's balance is a narrow path, and even small changes can tip it into violence. volcanic winters, asteroid impacts, sudden climate shifts, all can erase civilizations as easily as species. The archaeological record shows traces of smaller human-scale collapses echoing the same pattern: the drying of the Sahara, the eruption of Thera that shattered the Minoan world, the ash layers that blanket ancient cities. Each disaster reminds us how thin the fabric of civilization truly is. To imagine a civilization older than ours, one that rose and fell before written memory, we must remember that these events have not been rare. Catastrophe is the heartbeat of the planet. Every few tens of millions of years, extinction sweeps through life like a cleansing fire. Even within the span of human existence, massive volcanic eruptions have altered the course of history. The eruption of Mount Toba 74,000 years ago covered the sky with ash and may have reduced the human population to a few thousand breeding pairs. Genetic evidence still carries the echo of that bottleneck. Humanity nearly vanished once already, and that was only the most recent of countless near misses. What makes these resets so complete is not only the destruction of life, but the loss of evidence. When oceans rise, they erase coasts where early humans lived. When ice sheets grind over continents, they crush and carry away all trace of what lay beneath. When mountains rise, they bury the land that came before. Each geological process that shapes the planet also conceals its past. The deeper the record, the less we can know. Rocks recycle, sediments compress, and what is lost stays buried. Science has learned to read these erasures by subtle clues: isotopes in ocean sediments, trapped bubbles in ice, layers of volcanic ash. Each is a page of a book that has been mostly burned. From these fragments, we reconstruct a history of disaster and recovery. The pattern is unmistakable. The Earth resets life with ruthless regularity. Evolution adapts, diversifies, and climbs again from the rubble. Civilization, should it exist long enough, would be subject to the same laws. We are not separate from nature's cycles. We are part of them. In the modern age, we comfort ourselves with technology, believing it can shield us from catastrophe. But the planet has always outlasted its creations. The same forces that forged the continents will someday erase every trace of our cities. To the Earth, steel and bone are equally transient. What endures is the rhythm, the alternating pulse of creation and destruction, written not in myth, but in the rocks beneath our feet. If a civilization had once reached a level of advancement equal to or beyond ours, what event could have erased it so completely that only whispers remain? Could a volcanic chain like the Siberian traps, or an impact like the one that ended the dinosaurs, have reduced its works to dust? If so, would we even know where to look? The next step in this inquiry is to consider that question directly, to ask not only how the Earth resets itself, but how a civilization might vanish within that reset, leaving behind only geological fingerprints. The search for those fingerprints begins with a thought experiment, a question posed not by mystics but by scientists. What if civilization is not unique to humans? What if others, millions of years ago, reached an industrial age of their own, and the evidence has simply been lost to time? It is a hypothesis that tests the limits of geology and imagination alike, one that forces us to confront how little the Earth remembers. The next chapter will explore that idea, known as the Silurian hypothesis, a challenge to our assumption of uniqueness, and a reminder that even science must sometimes ask questions that seem impossible, simply to learn how to recognize the improbable, to understand how fragile civilization truly is. Imagine standing on the rim of a volcano as it wakes from centuries of sleep. The ground trembles beneath your feet. The air thickens with sulfur and ash. Within moments, the horizon becomes a wall of fire and smoke. What you are witnessing is not a rare spectacle. It is one of the planet's oldest and most consistent rhythms. For billions of years, the Earth has erupted, flooded, frozen, and burned, each time resetting its surface like a painter clearing a canvas. Catastrophes are not interruptions in the story of life. They are the punctuation marks that divide its chapters. The fossil record reads like a script of destruction followed by reinvention. The great volcanic fields of the Deccan Traps in India tell one such story. Around 66 million years ago, just before the asteroid that ended the age of dinosaurs, these eruptions poured out enough lava to cover the entire surface of the planet several meters deep. The gases they released transformed the atmosphere, setting the stage for the extinction that would follow. Whether the asteroid struck first or last almost does not matter. Both events combined to end one world and begin another. There is an eerie pattern in the timing of mass extinctions. Every few tens of millions of years, global ecosystems collapse. Some scientists have speculated about cosmic cycles, oscillations of the solar system through the galactic plane that might disturb comets in the outer regions, sending them earthward. Others see purely terrestrial causes, the build-up of volcanic gases, the slow dance of continental drift, or feedback loops in the climate. Whatever the cause, the pattern is real. The planet's stability is a temporary illusion. Human history, by contrast, occupies the thinnest slice of this record. Agriculture has existed for barely 12,000 years, writing for only 5,000, and industrial civilization for less than 300. To the Earth, that entire story would fit within a layer of dust no thicker than a single page. When we compare the brief span of human culture to the vastness of geological time, we begin to understand how easily it could vanish. A single eruption, a shift in ocean currents, or an asteroid no larger than a mountain could end it. The survivors, scattered and starving, might never rebuild. The idea that catastrophe could erase everything we know seems unthinkable. Yet every culture that has endured long enough to look backward has remembered one. The flood of Mesopotamia, the sinking of Atlantis, the fire that ended the previous sons of the Aztecs. All are echoes of real cataclysms. The planet's climate record supports them. Around the time those myths were first told, massive floods swept through river valleys as glaciers melted, raising seas and drowning coastal plains. To a people who had never seen such change, it must have seemed as though the gods themselves had turned against them. Today, geology gives those myths a new dimension. We now know that even in the relatively stable Holocene, abrupt climate shifts have occurred in mere decades. The Younger Dryas, for instance, may have dropped global temperatures by several degrees within the span of a single human lifetime. In Greenland's ice cores, layers of dust mark the sudden onset of cold, followed by centuries of famine and drought. The event ended as abruptly as it began, giving rise to the warmth that made modern civilization possible. In those few centuries of darkness, early cultures were tested to the limit. Some adapted, others disappeared entirely, leaving only scattered ruins for archaeologists to find 10,000 years later. If such volatility can occur within the recent geological past, what might have happened in deeper time? Suppose an intelligent species arose before us, reaching a level of development comparable to our own. A single event like the Toba eruption could have destroyed its food sources, darkened its skies, and reduced it to fragments within months. The survivors might leave behind traces, chemical residues, anomalous isotopes, but those too would be buried under layers of sediment. After millions of years, plate tectonics would subduct them into the mantle, where nothing human or otherwise can survive. The slate would be clean once again. Some scientists have suggested that if civilization had existed millions of years ago, the only evidence we might find would be indirect: changes in carbon isotopes, fossil fuel residues, or unusual minerals that require industrial processes to form. These would appear as anomalies in the rock record, mysterious spikes of chemistry with no apparent natural cause. Yet the record is full of such spikes, many still unexplained. Most can be attributed to volcanic activity or natural carbon cycles, but the mere fact that they exist reminds us how narrow our knowledge is. We know the outlines of the Earth's story, but its details are written in languages we are still learning to read. The irony is that our own civilization is now creating the very kind of geological signature that would confuse future scientists. Our burning of fossil fuels is altering the atmosphere, leaving a distinct layer of carbon and nitrogen compounds in the soil. Plastics and synthetic materials are becoming new kinds of sediment, forming what geologists call the Anthropocene layer. Millions of years from now, if anyone studies these rocks, they will see a sharp boundary between the natural world and one briefly dominated by industry. That boundary will look like a catastrophe, a sudden chemical anomaly marking a world transformed and then reset. In that sense, we are writing our own extinction into the Earth's memory. The same processes that would erase us also preserve us. Every factory, every vehicle, every particle of soot is part of a signature that says, "We were here." If another civilization once existed, its signature would be different, perhaps subtler, perhaps already erased. But the logic of geology remains the same. The planet forgets almost everything, yet it never forgets change. Each cycle of life and destruction is recorded in its bones. When we speak of resets, then, we are not speaking metaphorically. The planet truly does reset itself. It grinds down the old to make room for the new. Evolution adapts, invents, and begins again. Civilization, in all its complexity, is simply the latest experiment in that endless cycle. Whether it survives or not will depend on forces far older and greater than itself. The next step in this inquiry will not be to ask whether the planet can erase civilizations, we already know it can, but to ask whether it has done so before. That question leads us to a hypothesis both provocative and scientific, the Silurian hypothesis, an idea born not from fantasy, but from the sober realization that even an ancient industrial civilization might vanish without a trace. To explore that possibility, we must look for the faintest fingerprints in the deep record of time, the kind only geology and chemistry can reveal. When scientists first proposed that an asteroid had ended the age of dinosaurs, the idea was met with disbelief. The notion that a single event could rewrite the entire story of life seemed almost mythological. Yet as evidence accumulated, the iridium layer, the shocked quartz, the buried crater, the improbable became undeniable. The same skepticism now greets any idea suggesting that civilization itself might not be unique, that the Earth's history could include forgotten chapters of intelligence erased by nature. But if we have learned anything from the study of catastrophe, it is that the improbable happens with relentless regularity. To see the world as it truly is, one must learn to read destruction as carefully as creation. Every mountain range is a scar of collision. Every fossil bed is a graveyard left by catastrophe. The planet's crust is a palimpsest of violence rewritten countless times, and through that endless rewriting, life has persisted, adapting, forgetting, and beginning anew. Catastrophe is not an exception to evolution. It is its architect. Without extinction, there would be no innovation. Without the fall of one world, there could be no rise of another. From this perspective, the idea of a civilization reset becomes not only plausible, but almost inevitable. If nature has rebuilt ecosystems from dust, why could it not also erase and rebuild intelligence? The difference between a species of mammals and a civilization of machines is a matter of scale, not of possibility. The forces that ended the reign of dinosaurs would not hesitate to end ours. A single asteroid, a chain of volcanoes, or a shift in climate could erase every trace of human industry within centuries. The planet would heal, evolve, and move on, leaving behind a few anomalous layers for future geologists to puzzle over. The geological record is already full of such puzzles. There are abrupt rises in atmospheric carbon, sudden spikes in temperature, mysterious extinctions that defy simple explanation. Each could be the fingerprint of a natural event, or something more. Yet the deeper one looks, the more ambiguous the evidence becomes. After all, time does not preserve clean lines, it smudges and overlaps them. The signal of an ancient civilization, if it ever existed, would be almost indistinguishable from the signal of an unusually active volcano or a rapid climatic feedback. Even today, with all our technology, we struggle to isolate our own fingerprint amid the background noise of the planet's natural rhythms. The deeper lesson of catastrophe is humility. The Earth does not remember us in the way we remember ourselves. To the rocks, we are nothing but chemistry. The carbon from our breath, the metals from our machines, the isotopes from our reactors, all will eventually be absorbed into the slow dance of the crust. The continents will drift, new oceans will form, Mountains will rise where cities once stood. In 10 million years, the map will have changed beyond recognition. In 100 million, not even the shape of the continents will be familiar. What hope could there be for memory when the canvas itself is replaced? And yet, traces persist. Fossils form from bones. Ash layers record fire. Chemical signatures linger in sediments. Each is a whisper of what once was. To seek evidence of lost civilizations is not to indulge fantasy, but to test how deep those whispers can reach. If catastrophe resets the planet, it does not erase everything. It buries clues for those who come after. The challenge lies in recognizing them before they fade entirely. There is also a psychological aspect to this inquiry. Human minds crave stability. We prefer to believe that the ground beneath our feet is solid, that tomorrow will resemble today, that progress builds upon itself forever. The idea of total collapse feels unnatural because we live in a moment of apparent continuity. But continuity is the exception, not the rule. Every known civilization before ours has collapsed in one form or another. Some were consumed by drought, others by war, others by their own success. Each believed itself eternal until the walls began to crack. What we call progress may simply be the brief interlude between catastrophes. Even now, scientists studying ice cores and ocean sediments speak of thresholds, the tipping points beyond which climate or chemistry shifts irreversibly. They are the same kind of thresholds crossed many times before in Earth's history. The difference today is that one species can watch the change unfold in real time, aware of what it means, yet unable to stop it. In that awareness lies a strange kinship with all who may have come before. If any civilization ever faced its own undoing, it would have seen the same signs: skies darkening, harvests failing, oceans rising, and the slow realization that intelligence does not grant immunity from nature's cycles. Perhaps that is why the myths of destruction and renewal are so persistent. They are not mere stories of punishment or moral decline. They are encoded memories of something the planet itself remembers: the inevitability of change, the fragility of order. Flood, fire, and ice are not just metaphors. They are the vocabulary of geology. They describe how the Earth resets itself and begins again. To look for evidence of past civilizations, then, is not to search for cities or machines, but for the chemical ghosts of activity, for isotopes that do not belong, for minerals that should not exist without industrial heat. These are the fingerprints that might endure when all else is gone. The scientists who proposed the Silurian hypothesis understood this. They did not claim that such a civilization had existed. They merely asked whether it could have, and whether we would even know. This question leads us naturally to the next stage of inquiry. If a civilization could vanish so completely that only its chemistry remained, what would that chemistry look like? What traces could survive tens of millions of years of erosion and tectonic recycling? And if we were to find such traces, how could we distinguish them from natural events? To answer that, we must explore the scientific thought experiment that redefined how we think about deep time and intelligence. The Silurian hypothesis, a proposal that asks the most unsettling question of all: if others came before us, why can we not find them? Imagine a future scientist studying the rocks of our age millions of years from now. The continents will have drifted, oceans will have opened and closed, mountains will have risen and vanished. No buildings will remain, no metal, no glass, no books. Even the fossils of our bones will be rare. Yet the soil will carry subtle signs that something unusual once lived here: anomalies in carbon isotopes, synthetic chemicals that never existed before, traces of plastics and nitrogen compounds from industrial farming. That distant scientist, if they could read those clues, might conclude that a civilization once altered the planet and then disappeared. This is not fantasy. It is a scientific exercise known as the Silurian hypothesis. The term was proposed by two researchers, Adam Frank, an astrophysicist, and Gavin Schmidt, a climate scientist. They named it not after the modern science fiction race, but after the Silurian period. roughly 440 million years ago, when complex life was beginning to flourish in the seas. Their question was simple and audacious. If an industrial civilization had existed on Earth millions of years before humans, would we be able to detect it today? The answer, after careful reasoning, was unsettling. Probably not. The premise rests on the nature of the geological record. Earth is a planet that erases itself. The crust recycles through plate tectonics, burying and melting rock. Erosion, sedimentation, and ocean chemistry continually rewrite the surface. Over spans of tens of millions of years, almost all direct evidence of life's activity disappears. The oldest seafloor on the planet is less than 200 million years old. The continents preserve fragments older than that, but they too have been weathered, folded, and transformed. If our entire civilization were compressed into a few millimeters of sediment, would any of its technology survive? Frank and Schmidt's thought experiment did not begin with conspiracy theories or lost cities, but with climate science. They were studying the long-term carbon cycle, the way carbon moves between atmosphere, oceans, and rocks, and realized that an industrial civilization would leave a distinct but transient signature in that cycle. Burning fossil fuels releases carbon with a specific isotopic ratio. If a similar spike were found in ancient rocks, it could suggest a previous industrial phase of life. Yet the challenge lies in distinguishing such a signal from natural phenomena, like massive volcanic eruptions or methane releases from the seafloor. Nature, it turns out, is capable of imitating civilization. The Silurian hypothesis is not a claim that ancient civilizations existed, but a tool for humility. It forces us to confront how easily time erases even the grandest works. Consider how little of our own history survives intact. Entire cultures vanish from memory within a few centuries if their writings are lost. Now extend that process across millions of years, and the problem becomes clear. A global industrial civilization could rise, fall, and vanish, leaving behind nothing more than a thin chemical anomaly and a few altered minerals. Some skeptics argue that if such a civilization had existed, we would find at least some durable artifact, an alloy, a fragment of ceramic, a trace of engineered structure deep in the rock. Yet the Earth's crust does not preserve such things kindly. Metals corrode, ceramics shatter, pressure and heat transform all but the most inert materials. Even our most resilient creations, such as stainless steel or silicon, would degrade under the weight of time. In millions of years, their atoms would be redistributed into new forms. The odds of an artifact surviving long enough to be recognized as artificial are vanishingly small. Still, the search is not hopeless. The scientists who developed the hypothesis proposed several markers that could, in principle, outlast everything else. One is the global shift in isotopic ratios of carbon, oxygen, and nitrogen, signatures of massive chemical alteration of the biosphere. Another is the presence of synthetic compounds like chlorofluorocarbons or plastics, which do not occur naturally and degrade slowly under pressure. A third is the distribution of certain metals, such as aluminum or rare earth elements, which would show unusual concentrations inconsistent with normal geological processes. Each of these could act as a ghostly fingerprint, hinting at a vanished age of industry. The hypothesis also carries a philosophical weight. It challenges our assumption that intelligence is rare or new. If life arose quickly after the Earth formed, and if intelligence is a natural outcome of evolution, then deep time offers many opportunities for it to emerge. Perhaps it did, and the planet's cycles simply erased its memory. Or perhaps intelligence itself is self-limiting, always destroying its foundation before it can endure. In that sense, the Silurian hypothesis becomes not just a question of evidence, but a warning about survival. Our own civilization is now creating the very type of anomaly that scientists of the far future would look for. We are altering the carbon cycle, changing sediment chemistry, and leaving behind new materials that will become part of the rock record. Whether we survive long enough to read our own message depends on whether we can understand what those changes mean. The Silurian hypothesis is, in this way, a mirror. It reflects our future in the light of an imagined past. To consider that another civilization might have once existed on Earth is to realize how temporary even our dominance may be. We measure time in centuries, but the planet measures it in eons. Our species has existed for less than 0.1% of Earth's history. If intelligence has appeared before, its traces would now be ghosts buried under continents or scattered on the ocean floor. And if we are the first, we too will eventually become a ghost in the rock, a brief anomaly in the story of a world that endlessly forgets. The next step, then, is to look beyond theory and examine the record itself. Are there signs, however faint, of something that does not fit? Anomalies, unexplained artifacts or patterns in the geological record that suggest intervention beyond natural causes. The search must be careful, skeptical, and rooted in evidence. To separate signal from noise, we must look for the rare places where geology and archaeology meet, where myth and measurement might overlap. For it is in those strange intersections that the whisper of a lost civilization, if it exists at all, might still be heard. The Silurian hypothesis is less about believing in lost civilizations and more about testing the limits of what science can know. It asks a deceptively simple question: how complete is our record of the past? For all our satellites, supercomputers, and fossil archives, the truth is that most of the planet's history is hidden beneath our feet, unreachable and unrecorded. The crust is a restless ocean of stone, constantly folding, melting, and rising again. When viewed through that lens, the absence of evidence for ancient intelligence may say less about what never was, and more about how little of deep time we can actually see. Even on the surface, the record fades faster than we imagine. Consider our own cities. If abandoned today, they would crumble within a few centuries. Plants would break through concrete, iron would rust, and glass would collapse into powder. Within 10,000 years, forests would reclaim them. Within 1 million, glaciers or deserts would erase even their shapes. Within 100 million, the land they once occupied might have sunk beneath an ocean, or been reborn as part of a mountain range. The cycle of the planet does not allow monuments to endure. If a civilization once stood in the Carboniferous or Jurassic periods, the continents themselves would have carried its ruins down into the mantle long ago. Some scientists have noted peculiar anomalies in ancient strata. Sudden increases in certain carbon isotopes, spikes of heavy metals, or odd layers of clay suggesting chemical disruption. Most of these are naturally explained: volcanic eruptions, oceanic stagnation, or meteor impacts. But each anomaly also raises the question of whether any signal could ever be unambiguous enough to prove an artificial origin. The problem is one of indistinguishability. Natural events mimic the byproducts of industry so well that the two are nearly impossible to tell apart after millions of years. The irony is that nature itself behaves like a civilization at times, releasing gases, altering chemistry, and transforming climate on scales far beyond our own. The authors of the Silurian hypothesis emphasize this paradox. If we ever did find such evidence, how would we know it was artificial? A thin layer of altered carbon might look identical, whether it came from volcanoes or machines. A sudden extinction could result from an asteroid or a technological collapse. Even a global layer of synthetic material might be reinterpreted by future geologists as an exotic natural polymer formed under pressure. The deeper the time, the harder the signal becomes to read. The very processes that make Earth habitable also conceal its memory. This realization forces a shift in thinking. Instead of asking whether civilizations existed, we must ask what kind of evidence could survive long enough to be found. The answer, if any, lies not in artifacts, but in chemistry. Civilization is, at its core, a rearrangement of matter and energy. We dig, burn, refine, and synthesize. Each of those acts leaves a chemical trace. The global industrial signature we are leaving now, a change in isotopes, metals, and sediments, will outlast everything else. Millions of years from now, that signal might appear as a brief pulse of activity, a flash of complexity in the otherwise steady rhythm of geology. If the same pattern appeared elsewhere in time, it could suggest that we were not the first to reach this stage. The Silurian hypothesis also extends beyond Earth. It asks us to look at other worlds, Mars, Venus, even exoplanets, with similar curiosity. If civilizations can vanish so completely, How many might have done so across the galaxy? A world may bear the scars of life without any living memory of it. The atmosphere might hold the faintest residue of industry, detectable only as an imbalance of gases. In that sense, the search for ancient civilizations on Earth becomes a mirror of the search for life beyond it. The method is the same. Find the chemical footprints of intelligence long after the footprints themselves have vanished. This approach does not weaken science, it strengthens it. By considering how easily evidence disappears, we refine our understanding of what counts as proof. The hypothesis reminds us that skepticism is not the same as denial. It is a discipline of curiosity, an acknowledgement that knowledge has limits. Even if the answer is that we are alone and first, the question teaches us how to read the planet more carefully. It turns myth into testable science, imagination into a tool of measurement. Perhaps the most profound aspect of the Silurian hypothesis is what it reveals about time itself. Civilizations think in centuries, but the planet thinks in ages. What seems eternal to us is a moment to geology. A few thousand years of technology may feel like a destiny fulfilled, yet to the Earth it is a flicker, a single breath in a long cycle of birth, growth, and erasure. By imagining predecessors lost to time, we glimpse our own fragility. We see that survival depends not on dominance, but on harmony with forces that dwarf us. If ancient civilizations did exist, their end would not have been dramatic from a geological perspective. It would have been quiet, a slow fading of signals, a cooling of fire, an absorption of cities into soil. Time would have closed over them as gently as water over a stone. And yet, even that silence would not be complete. Somewhere, deep in the strata, the chemistry of their passing might still whisper. To find such whispers, we must look at the anomalies that challenge our assumptions, the strange artifacts, the misplaced stones, the layers that tell conflicting stories. These are not proofs, but puzzles. Some may be errors of dating, others misread signals, but a few remain unexplained, inviting speculation. The next chapter will turn to those anomalies, ancient sites, artifacts, and geological oddities that have sparked debate among archaeologists and skeptics alike. For if any evidence of a prior civilization exists, it would be hidden among these mysteries, waiting for those who know how to look without expecting what they want to see. The Silurian hypothesis invites a kind of scientific humility rarely practiced in modern thought. It forces us to confront the boundaries of what we can truly know about deep time. For all our satellites, instruments, and dating techniques, we have barely begun to read the full book of the planet. Most of its pages have been burned, rewritten, and buried. The oldest surviving rocks are but fragments of a vast story whose earliest chapters are forever lost. If an intelligent species had once risen and fallen within those vanished eras, the evidence of its existence would likely be indistinguishable from the natural record of extinction and renewal that defines the planet itself. The deeper lesson of this hypothesis lies in perspective. Humanity tends to see itself as unique, the pinnacle of evolution, the first species to master fire, language, and technology. But evolution has no favorites. Intelligence is a strategy, not a destiny. If it appeared once, it could appear again, and perhaps it already has, in cycles older than we dare imagine. The question is not whether another species once built machines or cities, but whether intelligence in all its forms inevitably destroys its own record before it can endure. When Frank and Schmidt proposed their thought experiment, they were not speculating about ancient aliens or lost empires. They were examining how industrial activity leaves planetary fingerprints. Those fingerprints, carbon isotope shifts, synthetic compounds, temperature spikes, are transient on the scale of deep time. They last for thousands or millions of years, but not forever. Eventually, they dissolve into the natural background of geology. From that perspective, our entire industrial age may one day be reduced to a single chemical smudge between layers of stone. It will look no different from the countless other anomalies scattered throughout the fossil record. What makes the hypothesis profound is that it turns the search for past civilizations into a mirror for our own. We can study how Earth would remember us, and through that, learn how it might once have remembered others. If we can barely preserve our own story for more than a few millennia, what hope would there be of recovering one that is millions of years old? The question becomes not whether others existed, but whether the conditions for their survival, both physical and cultural, were ever possible at all. The hypothesis also touches something psychological, something ancient in our imagination. Every culture has a story of a world that came before, the Golden Age, the Flood, the Lost Paradise. These stories may not describe literal civilizations, but they express a deeper intuition that history moves in cycles, that creation and destruction follow each other endlessly. The Silurian hypothesis gives that intuition a scientific shape. It tells us that the Earth itself behaves cyclically, and that civilizations like ecosystems may rise, fall, and vanish without trace. If we accept this as possible, we must also accept its implications for the present. Our species is now altering the climate and chemistry of the planet at a pace unseen in geological history. We are creating our own version of the thin chemical anomaly future scientists might puzzle over. It may last for millions of years, or vanish in thousands, depending on how the planet reclaims it. The irony is almost poetic. In searching for the ghosts of hypothetical predecessors, we are learning to recognize the ghost we are becoming. In this way, the Silurian hypothesis becomes both a scientific model and a cautionary tale. It teaches us that civilization is not measured by its technology or its reach, but by its ability to coexist with time. A society that burns too brightly may leave a scar but not a legacy. To endure, a civilization must learn to align itself with the rhythms of its planet, not fight them. Otherwise, it becomes another brief pulse in the endless heartbeat of the Earth. We might never find a definitive answer to the question of ancient precursors. The geological record will remain ambiguous, full of mysteries that can be explained in more than one way. But the act of asking sharpens our understanding of what survival truly means. If intelligence cannot preserve its own memory beyond the lifespan of continents, then perhaps the goal is not permanence but renewal, to ensure that the light of awareness rises again, even after darkness. There is a haunting beauty in that idea. The thought that we are part of a cosmic cycle of intelligence that appears, vanishes, and reappears across time does not diminish us. It connects us to the deep rhythm of the universe, to the same laws that shape stars and seas. Every civilization, known or unknown, becomes a verse in a poem written in matter and time. The Silurian hypothesis leaves us at a crossroads between science and wonder. On one side lies the disciplined skepticism of geology and climatology. On the other, the timeless human question of origins. Somewhere between them may lie the truth that history itself is larger than our memory, and that we are walking across the faint, eroded footprints of those who came before. To explore that possibility further, we must turn from theory to evidence, from thought experiment to the tangible anomalies scattered through the archaeological and geological record. The next chapter will take us there, to the stones, metals, and sites that challenge explanation. Some are misunderstood, some are natural, but a few remain stubbornly resistant to classification. If any traces of an earlier civilization still exist, they may be hidden among those enigmas, waiting for the patient and skeptical eye willing to see what others dismiss as impossible. The story of science is often told as a triumph of reason over superstition, of light dispelling darkness. Yet even within that light, there remain shadows, mysteries that refuse to yield, fragments that do not fit the pattern we expect. Archaeology, geology, and anthropology are full of such fragments. Some have natural explanations, others are errors of dating or context, and a few remain genuinely puzzling. These are the anomalies, the outliers that whisper of possibilities we are not yet ready to name. Among the most famous of these anomalies is a site buried under the Anatolian soil of modern Turkey, known as Göbekli Tepe. Discovered in the 1990s, it rewrote what we thought we knew about the dawn of civilization. The great T-shaped pillars, carved with animals and arranged in stone circles, date to around 11,600 years ago, long before agriculture, long before cities, long before writing. The people who built it were supposed to be hunter-gatherers, yet they created a monument of precision and scale that would challenge even later Bronze Age builders. Each pillar weighs many tons and is positioned with astronomical awareness. Then, as mysteriously as it was built, the site was buried by its own creators. No one knows why. Some say it was a ritual closure, others a preservation effort. Whatever the reason, it remained sealed beneath the earth for thousands of years, preserved like a time capsule from a forgotten world. Mainstream archaeology explains Göbekli Tepe as a product of social transformation. It marks, in that view, the beginning of organized religion and settled life, a step on the ladder of progress. But the site also raises uncomfortable questions. How did small groups of foragers gather the labor, engineering knowledge, and artistic skill required for such work? How did they quarry, transport, and erect pillars, weighing 20 tons without metal tools or domesticated animals? And why do similar megalithic traditions appear independently in distant parts of the world, often aligned to the stars? The answers may yet lie in the slow work of excavation, but for now, Göbekli Tepe stands as an elegant challenge to the notion that civilization began in a single linear arc. The world is dotted with other enigmas just as strange. Off the coast of Yonaguni in Japan lies a submerged structure of terraces and steps that some believe to be the ruins of an ancient city. The formations resemble platforms and stairways, yet geologists debate whether they are natural sandstone fractures shaped by currents. The ocean guards its secrets carefully. Rising seas at the end of the last ice age drowned vast areas of coastal land where early humans likely lived. Whatever settlements stood on those plains now rest beneath hundreds of meters of water and silt. Each sonar scan, each underwater discovery, feels like a whisper from that drowned world. Then there are the stones of Baalbek in Lebanon, massive blocks of limestone so large that modern cranes would struggle to move them. The largest, known as the Stone of the Pregnant Woman, weighs over 1,000 tons. The Roman builders who constructed the later temples there did not cut these colossal stones, they inherited them. The older foundation blocks seem to predate the Roman period entirely, their origin lost to history. Were they the remnants of an earlier culture, or simply the product of extraordinary engineering ambition? Scholars debate, and the stones remain silent. In South America, the ruins of Pumapunku near Lake Titicaca show stonework of astonishing precision. Blocks of andesite are cut with interlocking patterns, their edges sharp as if machined. Yet the tools used to shape them are unknown. Mainstream archaeologists attribute the site to the Tiwanaku civilization, around 1,000 years before the present, noting that skilled masons with copper tools and abrasives could achieve such work. Still, the perfection of the joints, the exact right angles, and the sheer complexity of the cuts continue to stir fascination. For those who look for traces of a lost high civilization, Pumapunku has become a symbol, an ancient puzzle that refuses to close. But we must be careful. For every genuine mystery, there are dozens of myths, misinterpretations, and deliberate fabrications. Human imagination is drawn to gaps in knowledge. When we do not understand how something was made, we invent stories to fill the void. The ancient astronaut theories of the 20th century are one example. Claims that extraterrestrials built the pyramids, that megaliths were power stations, that myths describe advanced technologies. Such ideas capture the imagination but often collapse under scrutiny. There is no evidence of alien intervention, nor of technology beyond the means of ancient humans. What remains are the artifacts themselves, marvels of creativity that speak to the forgotten ingenuity of early cultures, not to impossibilities. Yet even within accepted science, anomalies persist that deserve attention. In India's Gulf of Kambat, sonar scans in the early 2000s revealed geometric patterns beneath the silt. Artifacts retrieved from the area suggested human activity more than 9,000 years ago, far older than the Indus Valley civilization. The site remains controversial. Many geologists argue the formations are natural, others see deliberate design. The debate continues, illustrating how fragile interpretation becomes when the evidence lies beneath the sea. Geological anomalies also intrigue researchers. There are the so-called mystery spheres found in ancient rock formations in South Africa. Metallic-looking spheres with grooved surfaces, dated to billions of years. Most have natural explanations as concretions formed by mineral growth under pressure, yet they still provoke wonder. Then there are the cases of human-like footprints in unexpectedly old strata, tools found where they should not be, and isolated artifacts misdated or misidentified. Science, when it encounters such contradictions, must walk a narrow path between skepticism and openness. Dismissing anomalies too quickly risks arrogance. Embracing them uncritically invites delusion. The truth often hides somewhere between. The challenge is one of pattern. A single anomaly proves nothing, but a convergence of anomalies, a recurring theme of advanced knowledge appearing too early, or of missing links between technological leaps, can suggest gaps in our understanding of history. The rise of megalithic architecture after the last ice age, the sudden sophistication of agriculture and astronomy, and the global recurrence of flood myths may all point to a shared memory of disruption and recovery. These patterns do not prove a prior civilization, but they hint at a deeper rhythm: destruction, survival, and rebirth. Science thrives on questions that seem impossible at first. To ask whether anomalies are remnants of a forgotten chapter is not to reject evidence, but to expand the field of inquiry. Archaeology, geology, and climatology are learning to speak to one another in new ways. High-resolution satellite imaging, sediment core analysis, and genetic tracing of ancient populations are rewriting timelines every decade. The boundaries of knowledge are shifting, and with them, the possibility that fragments of the unknown might still lie buried in plain sight. We may never uncover definitive proof of a lost civilization, but the search for anomalies reveals something just as profound: the persistence of curiosity. The human mind is drawn to the edges of the known, to the questions that refuse to die. Each time we unearth a mystery, we also uncover our own desire to connect, to remember, to imagine continuity across the erasures of time. Whether or not history was ever truly reset, our search for its missing chapters reminds us of the fragility of memory and the resilience of wonder. If anomalies are the sparks, then the next step is to examine the dark spaces between them, the gaps in the record where entire worlds may have been lost. We must ask why those gaps exist, how preservation fails, and what forces hide the evidence of deep antiquity. The next chapter will lead us into that silence, exploring how erosion, tectonics, and the rising sea have conspired to erase the earliest chapters of the human story, and perhaps others that came before. When we study anomalies, it becomes clear that the boundaries between what is natural and what is man-made are not always as firm as we imagine. A structure carved by wind and water can look astonishingly like human architecture. A mineral formation can resemble an artifact. Over tens of thousands of years, erosion, compression, and sedimentation blur every line. Yet even knowing this, some discoveries retain an uncanny precision that defies easy explanation. The task, then, is not to indulge fantasy, but to look closely, patiently, and with a mind balanced between skepticism and awe. Take, for instance, the submerged ruins found along the coasts of India, Japan, and the Mediterranean. When sonar and submersible drones explore these drowned plains, they often find patterns that resemble roads, foundations, and walls. Many such features turn out to be natural, but not all. Off the coast of Malta, divers have mapped what appears to be a grid of massive stone blocks, the remains of structures that would have stood on land before the sea rose more than 100 meters at the end of the last ice age. The same is true off the coast of Egypt, where the ancient city of Heracleion, once thought to be myth, was rediscovered beneath the Nile Delta, preserved in silt. These findings remind us that the sea is both a destroyer and a guardian. It erases what it covers, yet keeps it from the weathering of air and time. Archaeologists estimate that during the last glacial maximum, when sea levels were far lower, As much as 20 million square kilometers of coastal land were exposed. These fertile regions would have been the ideal places for early human settlement. When the ice melted and the seas rose, those lands were lost. That means that a vast portion of early human history lies beneath the waves, inaccessible to conventional archaeology. If an advanced culture had existed during that time, most of its evidence would now rest on the ocean floor, buried under layers of sediment. What little we have found comes from the margins, tools, pottery fragments, and structures from regions that escaped submersion by chance. The absence of evidence, then, may be more a consequence of geography than of non-existence. Other anomalies appear in the stones themselves. In the quarries of Aswan, ancient Egyptian stonemasons left behind half-finished obelisks, showing how they cut massive granite blocks using pounding stones and abrasives. Yet in other sites, such as Sacsayhuaman in Peru, the stonework fits with uncanny precision, so tightly that even a knife blade cannot slip between the joints. The surfaces are irregular, yet they interlock like pieces of a puzzle. Some researchers suggest that the builders used advanced techniques for softening or shaping stone, now lost to time. Others argue that patience and craftsmanship alone suffice to explain it. The debate highlights an uncomfortable truth. The further we move from living traditions, the less we truly understand the full range of ancient human skill. Then there are anomalies of knowledge: mathematical, astronomical, and architectural. The Great Pyramid of Giza encodes ratios that correspond closely to the value of pi and to the curvature of the Earth. The builders may not have known these numbers as we do, but they understood geometry through direct observation. The alignment of the pyramid with the cardinal directions is so precise that even modern instruments struggle to improve upon it. Across the world, from Stonehenge to Chichen Itza, from the pyramids of the Yucatan to the stone circles of Nabta Playa, ancient builders oriented their monuments to the solstices, equinoxes, and the rising of specific stars. This consistency suggests a global fascination with the sky, perhaps rooted in shared necessity or memory. Skeptics point out that humans everywhere observe the heavens, and similar alignments arise naturally. True enough. Yet the persistence of such precision across continents and millennia is still remarkable. It hints at a kind of knowledge transmission not yet understood. Whether through trade, migration, or independent rediscovery, ancient people everywhere learned to track time by the stars. Some alignments even match patterns that no longer exist, as if the builders recorded a sky from a different epoch, when the Earth's tilt and precession placed constellations differently along the horizon. These discrepancies can be explained through astronomy, but they also show how ancient memories sometimes reach deeper into time than we expect. Artifacts, too, sometimes emerge from the ground that seem to defy chronology. The so-called Antikythera mechanism, recovered from a shipwreck off Greece, is one of them, a bronze device with interlocking gears that function as an analog computer for predicting celestial events. For decades, scholars assumed it was an isolated marvel. Yet similar fragments have since been found, and the mechanism's design is now recognized as the product of a sophisticated tradition of mechanical astronomy that later vanished. Its rediscovery proves how easily knowledge can disappear, and how its recovery can seem miraculous when viewed out of sequence. Even more controversial are the so-called out-of-place artifacts, objects reportedly found in geological layers far older than humanity itself. Stories abound of metal spheres, hammers embedded in stone, or carvings discovered in coal seams. Most of these claims collapse under investigation. Samples are misidentified, layers disturbed, or the context lost. But a handful of such reports remain genuinely puzzling, their details too incomplete to dismiss yet too uncertain to prove. They linger as footnotes in scientific journals, reminders that curiosity often begins where certainty fails. To examine anomalies is to confront the limits of evidence. Science advances by ruling out what is false, but anomalies resist such clean resolution. They dwell in the margins where interpretation depends on context, and context is fragile. A single misdated sample can shift an entire timeline. A missing layer of sediment can erase centuries. In that sense, anomalies are not merely curiosities. They are indicators of how incomplete our record truly is. Each one reveals a gap, a silence, a region of the past not yet illuminated. And perhaps that is their true significance. Whether natural or artificial, explained or not, anomalies remind us that the past is larger than our narratives allow. They force us to keep asking, to keep testing, to admit that our story of civilization may be provisional. For all the confidence of modern science, we still navigate by fragments, inferring worlds from traces. The myth of certainty is as deceptive as the myth of progress. If history has been reset before, the signs of that reset would not appear as perfect ruins or intact machines. They would appear as patterns of absence, eras of disruption, layers of mystery, scattered hints that something once was and is no longer. To understand those absences, we must study not only the anomalies that survive, but the processes that erase them. The next chapter will turn to those forces of loss: erosion, submersion, tectonic movement, and time itself. For if a civilization truly vanished from the record, it is in those natural mechanisms of forgetting that its story would be buried. Anomalies are like whispers carried across time, half-truths, faint echoes that challenge the certainty of our historical narrative. They invite imagination, but they also demand rigor. For every extraordinary claim, there must be extraordinary evidence. The difficulty lies in how evidence behaves under the weight of ages. It decays, it migrates, it hides. What survives to reach us is rarely the full picture, and what we interpret may be no more than a reflection of our own expectations. The task of the investigator, then, is to stand between wonder and skepticism, seeing both as necessary tools of truth. Consider again Göbekli Tepe. The more archaeologists uncover, the more questions arise. Beneath its great rings of pillars lie older layers still unexcavated. The carvings show animals not just of the region but of faraway lands, as if the builders carried memories of climates and creatures beyond their immediate world. The art displays an awareness of symbolism and abstraction that seems far advanced for its supposed time. Some researchers now believe that the monument marks not the beginning of civilization, but its remembrance, a gathering of survivors who built in stone what they could no longer sustain in life. The burial of the site might then represent an act of closure, the sealing of a chapter whose story we will never fully read. In the Americas, similar mysteries emerge. The city of Caral in coastal Peru, dating to roughly the same era as the Egyptian pyramids, appears to have risen without warfare, built on trade and ritual. Its architecture and astronomy suggest a cultural sophistication unexpected for a world still thought to be primitive. Across the ocean, the ruins of Nan Madol in Micronesia stand upon artificial islets built from basalt columns weighing tens of tons, transported without wheels or beasts of burden. The oral traditions of the island speak of its builders as beings who came from the stars, but such myths may simply preserve the memory of ancestors whose technology and organization later generations could not replicate. What binds these sites together is not proof of lost high technology, but the persistent pattern of premature sophistication. Again and again, we encounter civilizations that appear to emerge fully formed, without the gradual build-up one would expect. The pyramids of Egypt, the ziggurats of Mesopotamia, the Moai of Easter Island, the city planning of the Indus Valley, all seem to begin at their peak and then decline. It is as if they inherited knowledge rather than invented it. Mainstream archaeology explains this as convergence, the natural outcome of human creativity responding to similar needs. Yet the coincidence remains striking. The same architectural motifs, the same fascination with astronomy, the same orientation toward celestial cycles recur across continents long before global communication existed. Could there have been a shared origin, a cultural ancestor dispersed and half forgotten after a global catastrophe? It is a possibility that sits uneasily between myth and science. The great flood stories of the world, the Mesopotamian deluge, the biblical narrative of Noah, the Hindu legend of Manu, the tales of Deucalion in Greece and Utnapishtim in Sumer, all describe a disaster that erased the old world and gave rise to a new one. For centuries, scholars regarded these as allegories. Then, geological research revealed that at the end of the last ice age, the planet experienced sudden and massive flooding as glacial lakes burst and sea levels surged. The timing matches the appearance of many post-flood civilizations. Myth, it seems, may encode memory and metaphor. Even within the more recent archaeological record, strange disjunctions persist. At Tiwanaku in Bolivia, carvings depict animals long extinct in the region, suggesting either immense antiquity or a memory reaching back to a different environment. In the ruins of Tiahuanaco and Pumapunku, stones appear weathered far beyond what a few thousand years should produce, hinting at construction phases older than the current dating allows. In Egypt, erosion patterns on the Sphinx enclosure resemble those caused by heavy rainfall, something that last occurred before the Sahara became a desert. If true, that would push the monument's origins far earlier than dynastic Egypt. Most geologists attribute the weathering to other causes, yet the debate remains open, unresolved after decades of study. Science proceeds by caution, not conviction. It is right to question every extraordinary interpretation, but skepticism must cut both ways. To insist that the timeline we have constructed is unassailable is itself a kind of dogma. The past is not a static script. It is a palimpsest of incomplete lines rewritten by time. Each discovery, each anomaly, each contradiction adds another layer of complexity. To dismiss them entirely because they do not fit our model is to confuse comfort with truth. Perhaps the real significance of anomalies is not that they prove a lost civilization, but that they remind us how much remains unknown. They tell us that human history, even within its known span, has undergone cycles of forgetting and rediscovery. Technologies vanish, knowledge erodes, and entire cultures disappear, leaving behind only fragments to perplex their descendants. The Antikythera mechanism is a perfect example of such loss, a single surviving piece of a forgotten science that once measured the movements of the heavens with astonishing precision. If such sophistication could arise and vanish within a few centuries, what might have been lost in tens of millennia? To walk among ancient ruins is to feel that question in the bones. The stones themselves seem to breathe memory, their surfaces worn by generations who knew more than we assume. Whether those builders were the first, the last, or merely one among many in a repeating cycle of creation, their legacy is the same, a warning against arrogance, a reminder that the measure of civilization is not permanence but resilience. And so, from these scattered anomalies, we turn to a deeper enigma, the spaces between them. If history has indeed been reset, the most telling clues will not be found in what survives, but in what is missing. Gaps in the record, erased coastlines, vanished cultures, and silences in the sediment all point toward an unseen pattern of loss. The next chapter will follow those silences, exploring how the Earth's own forces, erosion, subduction, flood, and fire, can erase entire civilizations so completely that only the faintest geological whispers remain. When we imagine the story of human history, we often see it as an unbroken thread, a line of ascent from primitive beginnings to modern complexity. But the Earth tells a different kind of story, one full of missing chapters, torn pages, and rewritten lines. For every site we uncover, there are thousands lost to erosion, buried beneath oceans, or recycled into the crust. The geological record is not a perfect archive. It is a selective memory, shaped by time and violence. What we call prehistory is simply the portion of the past that the planet has forgotten to preserve. Archaeologists know this all too well. The record of early humanity is astonishingly thin. For every artifact found, millions must have perished. A wooden tool left in the open air rots in a few years. Textiles vanish in decades. Even stone erodes. Most of the evidence that survives comes from accidents of preservation, dry caves, volcanic ash, or oxygen-poor bogs that shield fragile materials from decay. If not for these rare conditions, we would know almost nothing about our ancestors. And that is only the recent past. Extend this problem back tens of thousands of years, or hundreds of thousands, and the silence becomes almost total. The first civilizations we recognize, Sumer, Egypt, the Indus Valley, and China, arose between 6,000 and 5,000 years ago. Yet humans identical to us in body and mind existed for at least 300,000 years before that. What did they do in all that time? The archaeological record offers glimpses, tools, cave art, traces of dwellings, but not enough to form a continuous picture. Entire cultures could have risen and fallen within those gaps, leaving no trace that would survive more than a few millennia. The absence of evidence is not evidence of absence. It may simply mark the places where preservation failed. The ocean conceals much of that failure. During the last ice age, sea levels were more than 100 meters lower than today. Great stretches of continental shelf that now lie underwater were once fertile plains and river valleys. These would have been the most habitable regions on Earth, rich in food, mild in climate, and ideal for early settlement. When the ice melted and the seas rose, those lands disappeared. Archaeologists estimate that at least 10 million square kilometers of prehistoric landscape now rest beneath the waves. Whatever was built there is hidden beneath sediment, beyond easy reach of exploration. Consider the ancient coastlines of the Indian subcontinent, now submerged beneath the Arabian Sea. Sonar surveys have revealed what appear to be geometric formations and river channels on the seafloor, suggesting that entire urban landscapes may once have existed where water now rules. In Southeast Asia, legends speak of the drowned land of Sunderland, a vast plain that connected the islands before rising seas tore them apart. Genetic studies hint that ancient populations indeed lived there and were displaced by flooding. Yet direct evidence is elusive, trapped beneath silt and time. Even on land, erosion is a merciless editor. Wind and rain carve away the surface layer of history year after year. In temperate climates, soil turnover can destroy archaeological deposits within a few thousand years. In tropical regions, organic material decomposes even faster. The great civilizations of the Amazon, once thought mythical, are only now being revealed by satellite imaging that detects geometric earthworks beneath the forest canopy. For centuries, the jungle had erased them so completely that explorers assumed the region was untouched wilderness. What other forgotten cities still lie hidden, disguised by forest or desert? The same principle applies on a geological scale. Plate tectonics constantly recycle the crust, drawing ancient seabeds deep into the mantle. Rocks older than 200 million years are rare because the Earth renews itself. That means the surface we walk upon is temporary. If a civilization had existed hundreds of millions of years ago, its cities would long ago have been subducted and melted. Even within the more recent span of human existence, the forces of glaciation, flood, and volcanic activity can obliterate entire regions in moments. The explosion of Mount Tambora in 1815 erased villages without leaving a trace. The eruption of Santorini in the Bronze Age buried a thriving culture beneath meters of ash. These are small examples of what nature can do on larger scales. Gaps in the archaeological record are not evenly distributed. Some regions appear to go silent for thousands of years, only to bloom again with sudden complexity. The transition between the Paleolithic and Neolithic periods, for example, remains poorly understood. We know that agriculture appeared independently in several regions at roughly the same time, around 12,000 years ago, but we do not know why. Was it a response to climate stability after the Younger Dryas cooling, or the inheritance of knowledge preserved through oral tradition from an earlier epoch? The record cannot tell us. The ice erased much of what came before. In Europe, the gap between the end of the Ice Age and the rise of organized farming is filled with scattered clues. Hunter-gatherer camps, cave art, and stone circles. But there are long stretches where the evidence thins to nothing. In the Near East, layers of occupation in ancient cities often show abrupt breaks, suggesting abandonment and reoccupation. Whether caused by drought, migration, or disaster, these interruptions fragment our understanding of continuity. Each gap forces archaeologists to reconstruct history from fragments, filling the void with hypothesis and inference. There is a strange paradox in all this. The further we advance in technology, the more we realize how incomplete our knowledge of the past truly is. Remote sensing, ground-penetrating radar, and genetic sequencing reveal patterns that contradict older models. Ancient trade networks appear far older and more extensive than once thought. Megalithic building traditions spread with surprising speed across continents. Myths once dismissed as fantasy now find echoes in geological and climatic data. We are, in a sense, rediscovering the outlines of forgotten stories that the Earth tried to erase. The implication is sobering. If our own civilization were to vanish today, what would remain in 10,000 years? In 100,000? Within 1,000,000 years, nearly everything we built would be gone, reduced to trace minerals and disturbed sediments. The written word would dissolve. Plastic and glass would fragment into dust. The tallest buildings would crumble, their steel turning to rust. Only a few durable artifacts, perhaps the Great Wall of China, Mount Rushmore, or the pyramids, might endure, and even those would eventually fade. The idea that nothing could erase us is an illusion born of short memory. The Earth has swallowed greater empires than ours without a trace. To study the gaps in the record is therefore to study the mechanics of forgetting. Time does not erase evenly. It selects what to keep and what to lose. Volcanic ash can preserve a moment forever, while rain can wash away centuries. The discovery of one fossil can redefine an entire species, just as the loss of one site can obscure the rise of a culture. History, like memory, is shaped as much by what vanishes as by what survives. The question, then, is not whether we are missing pieces of the human story. We clearly are. But whether those missing pieces hide something larger, a pattern of resets, cycles of civilization that rose and fell long before recorded history. If such resets occurred, they would not leave behind intact cities or artifacts of metal and glass. They would leave chemical signatures, abrupt changes in climate, and layers of sediment disturbed by human hands. To find them, we must turn to geology, to the deep archives of stone and ice that record the Earth's long memory. The next chapter will follow those records into the planet itself, into the cores of glaciers and the sediments of the ocean floor, where chemistry and isotope ratios tell a story beyond archaeology. For if civilization has ever been erased and reborn, the rocks may still remember what the ruins cannot. To understand the gaps in the record, we must first understand how fragile that record truly is. History, as written by the planet, is not a seamless scroll but a fractured mosaic, one built from accidents of preservation and blind luck. Every artifact that survives, every fossil, every trace of a vanished world exists only because it escaped the slow machinery of destruction that operates everywhere on Earth. Wind, water, heat, and pressure are the editors of time, rewriting the story with every passing age. Imagine a city like ours, abandoned and left to decay. Within 1,000 years, its concrete would crumble and its metal skeletons would rust into dust. Within 10,000 years, vegetation would have reclaimed every street, rivers carving new channels through forgotten suburbs. 100,000 years later, glaciers or deserts would scour the land clean. By the time 1,000,000 years had passed, nothing of the city would remain but a faint chemical trace in the soil, perhaps a layer of odd isotopes or particles of alloy, too evenly distributed to be natural. Multiply this process across continents and epochs, and the scale of the planet's forgetfulness becomes almost absolute. The gaps in the record are not empty by chance. They are the rule, not the exception. The geological record that archaeologists depend upon is a mere patchwork of the last few 100,000 years. Even the Holocene, the brief interglacial period that encompasses all of recorded human history, occupies less than 1/100th of 1% of the planet's age. Each earlier age is separated from the next by erosion and subduction, like chapters burned between rewritings. The deeper we look, the more complete the erasure becomes. This selective preservation gives rise to an illusion of continuity. When we dig at ancient sites, we often find layers of habitation stacked neatly one atop the other, mud brick over stone, pottery over ash. It seems as if history flows smoothly forward. But between one layer and the next, there may be centuries or millennia of silence. gaps where entire cultures flourished and vanished without leaving a trace. The deeper the excavation, the wider those silences become, until the story collapses into fragments. Archaeologists sometimes speak of archaeological visibility, the measure of how much of the past can still be seen. For most of human existence, that visibility is almost zero. Consider the period between 40,000 and 10,000 years ago, a span in which anatomically modern humans spread across the globe. We know that these people hunted, painted caves, carved figurines, and built temporary shelters. Yet we have no record of their politics, their myths, their social structures. We know nothing of their music or language, their beliefs or ambitions. For 30,000 years, the planet was full of humans who were fully capable of thought and culture, and yet the record holds only scattered fragments of bone and pigment. If civilization had risen and fallen in that time, how would we know? The problem becomes even deeper when we consider regions where natural processes erase evidence faster than it can accumulate. In river valleys, floods scour away layers of habitation. In volcanic zones, lava buries entire landscapes. In deserts, wind and sand grind stone to dust. The Sahara, now barren, once held lakes and forests. The same is true for the Arabian Peninsula and parts of Australia. The people who lived there left faint traces, stone tools, hearths, but nothing of permanence. In these regions, the past is not only lost, it is actively overwritten each generation by the forces of nature. There is also the matter of bias in discovery. Archaeology depends on where we choose to look. Most known sites lie in areas accessible to modern researchers, dry, stable regions where stone survives. But many of the world's ancient populations lived in coastal zones, now underwater, or in forests now impenetrable. Our sense of history is therefore shaped by what we can reach, not by what truly existed. As technology advances, through LiDAR scanning, sonar mapping, and satellite imaging, we are beginning to glimpse what the jungle and the sea have hidden. Ancient road networks beneath the Amazon, pyramids buried under sand in Sudan, circular structures in the Sahara that may have served as calendars or temples. Each discovery expands the map of human history, yet it also exposes how incomplete our previous understanding was. Even written history, which feels so stable, suffers from similar erasure. The Library of Alexandria once held the knowledge of centuries, and its destruction wiped out much of what the ancient world knew. The Maya recorded their history on bark manuscripts, nearly all of which were burned by Spanish priests. The great cities of Mesopotamia were abandoned, their clay tablets left to dissolve in the rain. If such erasures could occur within the last few thousand years, an eye blink in geological time, how much more must have vanished before writing even began? We are left then with an asymmetry. We remember recent centuries in microscopic detail, but as we move backward, the image blurs until it disappears entirely. It is within this blur that hypotheses of lost civilizations take root, not as conspiracy, but as recognition of ignorance. The gaps are not empty, they are full of lost information. Somewhere within them, perhaps, lie the ghosts of experiments in civilization that the Earth has already forgotten. This idea need not be speculative. Even within recorded history, humanity has undergone near collapses. Dark ages where writing ceased, trade broke down, and knowledge vanished, only to be rediscovered later. After the fall of Rome, literacy in Europe shrank to a few monasteries. The sciences of Greece were lost for centuries. The same pattern appears elsewhere: the fall of the Maya, the disappearance of the Indus Valley civilization, the decline of the Minoans. Each collapse created a localized reset, a break in continuity. Extrapolate that pattern across deeper time, and the possibility of a global reset becomes not a fantasy, but an extrapolation of what we already know to happen on smaller scales. Perhaps the most haunting aspect of the gaps in the record is that we might already have overlooked the evidence we seek. What if the chemical traces of an earlier civilization lie in sediments we have sampled, but misinterpreted as volcanic anomalies? What if a stone cut by ancient hands lies buried in a core drilled for oil, dismissed as a curiosity? The line between data and noise is drawn by expectation. We find what we are trained to look for. To see beyond the gaps, we must first imagine that the missing chapters exist, and so the silence of the record becomes not a barrier, but an invitation. If the planet has forgotten, we must learn to ask its memory in a new language, the language of chemistry and geology. The stones and the ice remember differently than ruins or myths. They carry the signatures of global change, locked in isotopes and microfossils, impervious to time. The next step then is to follow those signatures into the deep earth, where the record of catastrophe and renewal lies written in layers invisible to the naked eye. In the next chapter, we will enter that archive, the geological memory of the planet, to seek the traces that might outlast every civilization. For if the Earth has ever been reset, it is there, in the isotopic whispers and mineral scars of deep time, that the evidence would endure. To read the Earth's history properly, one must learn to think like the planet itself. Time, for the Earth, is not measured in reigns or dynasties, but in cycles of stone and sea. What seems eternal to us, a city, a civilization, even the human species, is to the planet only a transient experiment. Over geological time, everything on the surface is erased or transformed. Mountains rise, continents drift, oceans open and close. The rocks remember, but their memory is coded not in words or monuments, but in chemistry and structure. If we wish to recover what the planet has forgotten, we must learn to read those codes. Geologists describe the record of the Earth as a stratigraphy, a layering of sediment that captures events through their material traces. Each layer holds the residue of an age: ash from volcanoes, dust from deserts, shells from vanished seas. In some places, the layers are continuous, telling a nearly complete story. In others, they are broken, interrupted by erosion, or missing entirely. Those interruptions are called unconformities, gaps where time has been lost. They can last millions of years, erasing entire epochs from the record. An unconformity is a kind of amnesia, the geological equivalent of a missing page in a chronicle. These missing pages appear everywhere. In the Grand Canyon, there is a gap of more than 1 billion years between two layers of rock, a span longer than the existence of complex life itself. Across Africa, Asia, and the Americas, similar absences punctuate the crust, erasing countless details of what once was. For most of the planet's surface, less than 1% of its entire history is preserved in accessible form. The rest is lost beneath newer stone or melted into the mantle. It is within these absences that the imagination inevitably begins to ask, what stories were once written here? What events unfolded in the vanished time between layers? The same logic applies to the story of humanity. Our archaeological record is, in essence, a fragile stratigraphy of culture. The deeper we dig, the more discontinuous it becomes. We find clusters of activity separated by long silences, centuries or millennia where the evidence disappears. Sometimes these silences coincide with known disasters, droughts, ice ages, volcanic winters. At other times, the cause is unknown. These breaks are not minor. They define the edges of civilizations. Between the ruins of the Indus Valley and the rise of Vedic culture lies a 1,000-year void. Between the collapse of the Bronze Age and the ascent of classical Greece lies another. Such voids make it difficult to trace continuity, leaving open the possibility of partial resets, eras where knowledge and technology were lost and had to be reinvented. When these smaller collapses are viewed through the lens of geology, they form part of a larger pattern. The Earth's climate over the past 100,000 years has swung violently between extremes. Ice ages come and go in rhythmic cycles governed by shifts in orbit and tilt. Each transition redraws coastlines, transforms ecosystems, and forces migrations. Civilizations that depend on stable conditions can thrive for a few thousand years, but when the climate turns, they falter. Floods, droughts, and cooling events leave their scars not only on human memory, but in the sedimentary layers themselves. To the geologist, those layers look like a pulse of trauma, a thin, dark line of ash, a shift in isotope ratios, a sudden change in microfossils. To the historian, they correspond to myth and upheaval. It is no coincidence that many of humanity's origin myths speak of floods, fire, or darkness. These are the memories of real catastrophes, passed down and transformed through generations. The Younger Dryas cooling event, for example, brought abrupt temperature drops across the northern hemisphere about 12,800 years ago. Its onset and ending were both violent, possibly triggered by meltwater floods, or even by a cosmic impact. For the people alive at the time, it must have felt like the end of the world. Glaciers advanced, crops failed, and animal populations collapsed. In such conditions, any organized culture would have struggled to survive. If complex societies existed before that time, their remains would now lie beneath the silt and sea of post-glacial landscapes. Even today, the consequences of such events remain visible. Sea level rise at the end of the Ice Age inundated coastal plains from Southeast Asia to the Americas, drowning settlements and altering migration routes. In places like the Black Sea, rapid flooding created myths of deluge that persisted for thousands of years. Beneath the Mediterranean and the North Sea, archaeologists have identified drowned river valleys, once fertile lands now buried under mud. Each represents a vanished world, erased not by war or decay, but by the slow mechanics of climate. These natural erasures make the absence of evidence almost inevitable. To expect an unbroken record of civilization through such turmoil is to misunderstand how fragile the surface of the planet really is. Human history, even recent, is written on a medium that constantly erases itself. That we have any record at all is a miracle of circumstance. The Earth is not an archive, it is an artist constantly repainting its own canvas. And yet, the gaps themselves are clues. The places where data vanish, where timelines break, and where layers thin or stop entirely are the most telling features of the record. They mark the boundaries between ages, the thresholds where old worlds end and new ones begin. If the history of civilization includes more than one beginning, those beginnings would coincide with these silences. In this way, the absence of evidence becomes evidence of its own, a sign that something once stood there, too brief or too fragile to survive. We stand, then, before a paradox. The more completely the Earth renews itself, the less we can know of its past. And yet, without that same renewal, we would not exist. The forces that erase memory are the same forces that make life possible. The resets of geology and climate are both destroyers and creators. Each one clears the stage for new forms, new species, and perhaps new civilizations to rise. To find proof of such resets, we must follow the clues left not in ruins or myths, but in the chemistry of the planet itself. The isotopic ratios of carbon and oxygen, the presence of heavy metals or synthetic compounds, and the peculiar rhythms of sedimentation may all serve as fingerprints of catastrophe and renewal. The next chapter will enter this deeper stratum, the geological memory that speaks in elements and minerals rather than words. There, in the silent layers of rock and ice, the story of every reset, natural or otherwise, awaits decoding. If a civilization once rose and fell before ours, long before the earliest known empires of Sumer or Egypt, its traces would not be found in artifacts or ruins, but in the chemistry of the planet itself. Stone erodes, metal corrodes, and cities crumble, but the Earth records every global change in its own quiet way. The story of the planet is not written in words or symbols, it is written in isotopes, in minerals, in layers of ash and carbon buried deep beneath our feet. To look for evidence of a forgotten epoch of civilization, we must search within these archives, the geological memory of the world. The question is both elegant and haunting. Could an industrial civilization, one that once harnessed energy, altered its environment and shaped the biosphere, leave a detectable fingerprint after millions of years? In 2018, the physicist Adam Frank and the climatologist Gavin Schmidt proposed an experiment of thought they called the Silurian hypothesis. They asked, if a civilization had existed on Earth long before humans, how would we know? Would it be possible to detect its presence through geological records alone, even if all direct evidence had vanished? The name was a nod to science fiction, to the reptilian Silurians of British television, imagined as an ancient intelligent species predating humanity. But the question itself was serious. It forced scientists to confront how transient our own existence might be, and how difficult it would be to prove the existence of any that came before. The Earth's crust is a restless thing. Over tens of millions of years it moves, melts and reforms. Continents drift, collide and sink. The ocean floor is replaced entirely every 200 million years as tectonic plates recycle their surfaces into the mantle. This means that nearly all rocks older than that age have been destroyed or buried beyond reach. Even within younger sediments, the preservation of fine chemical signals depends on luck. A flood, a volcanic eruption, or a simple shift in current can scatter or dilute a trace beyond recognition. So if a civilization had existed in deep time, its physical remnants, its buildings, tools and technologies would be gone. Only subtle geochemical anomalies might remain. What kind of anomalies could reveal such a presence? One might expect artificial compounds that do not occur naturally, such as certain plastics or synthetic organics. But these decay, and in a few million years would be broken down into simpler hydrocarbons indistinguishable from natural sources. More enduring would be changes in carbon isotopes caused by large-scale combustion of fossil fuels. When humans burn coal and oil, we release carbon with a distinct isotopic signature, light in carbon-13 relative to carbon-12, into the atmosphere. This ratio is measurable in the geologic record. Future scientists, studying sediments from our time, would see a sudden and dramatic negative shift in the carbon isotope curve, a global marker of industrial activity. Frank and Schmidt argued that if a previous civilization had also used carbon-based fuels, its own industrial epoch might have left a similar isotopic fingerprint, a sudden perturbation in the carbon cycle, followed by rapid climate change. Such an anomaly could easily be mistaken for a natural event, like the Paleocene-Eocene thermal maximum 56 million years ago, when global temperatures rose abruptly by 5 to 8 degrees Celsius and carbon isotopes shifted strongly negative. The cause of that ancient warming remains debated. It may have been triggered by volcanic outgassing or methane release from the ocean floor, but it could also, hypothetically, be consistent with industrial-scale carbon emissions from a civilization now erased. The hypothesis is not that this was the case, but that we would struggle to distinguish between the two possibilities. Another potential marker is the distribution of rare earth elements or heavy metals. Modern industry concentrates these materials, copper, lead, nickel, and uranium, far beyond natural levels. If such concentrations were buried and preserved, they might form distinctive bands in the sedimentary record. Similarly, the production of nitrogen fertilizers alters the isotopic ratio of nitrogen in soils and oceans, creating a pattern that future geologists could detect. Our plastics, though destined to decay, leave microfragments that settle into sediments. Already, scientists have coined a term for rocks fused with plastic: plastiglomerates. These will persist for millions of years, a clear boundary between the natural and the human-made world. The Earth's archives are filled with comparable signals from past events. The Great Oxidation Event 2.5 billion years ago, when photosynthetic life began releasing oxygen, transformed the chemistry of the oceans and atmosphere. The Cambrian explosion left traces in the sudden abundance of calcium phosphates and carbonates. The end Cretaceous extinction, which ended the age of dinosaurs 66 million years ago, is marked by a thin layer of iridium, an element rare on Earth but common in asteroids, spread across every continent. These are planetary signatures, changes in global chemistry caused by biological or cosmic processes. A civilization large enough to reshape its environment would produce similar signatures. The question is not whether such signals could exist, but whether we could recognize them as technological rather than natural. Even now, our own signal is forming. The top layer of the planet's sediment, what geologists call the Anthropocene boundary, is unlike any before it. It contains fallout from nuclear tests, elevated carbon dioxide levels, synthetic polymers, aluminum alloys, fly ash from fossil fuels, and chemical fertilizers. It will endure long after cities have crumbled. In 10 million years, if intelligent beings were to study this layer, they would find an abrupt global transformation an event that looks instantaneous on the geological timescale. They might not know what species caused it, but they would know that something dramatic occurred. The Silurian hypothesis turns this perspective backward. If we can identify our own signal, we can also ask, are there any similar signals in the deep record that lack a natural explanation? Some scientists have searched for such anomalies, unusual spikes in certain isotopes, unexplained shifts in sediment composition, mysterious metallic concentrations, but none so far require invoking intelligent activity. Each has plausible natural causes. The Earth is full of chaotic systems, and coincidence often mimics design. That is why extraordinary claims demand extraordinary evidence. Yet even without direct proof, the exercise is valuable. It reminds us of how precarious our existence is in geological time. If our entire civilization vanished tomorrow, its detectable trace would be a thin film, no thicker than a sheet of paper in the Earth's crust. After 10 million years, that layer might survive only in isolated pockets. After 100 million, even those would be gone. From the vantage point of deep time, our age is a flicker, a momentary experiment that may or may not repeat. The search for geological signatures of civilization is, in the end, a mirror. It forces us to see ourselves not as the inevitable product of evolution, but as a phase, one of many that the planet may host. Our buildings, our machines, our vast consumption of energy, all these are simply another form of sedimentation, another pattern etched into stone. Whether we are the first to make that mark or merely the latest is, for now, unknowable. But in seeking that answer, we also glimpse something profound. The planet forgets almost everything, but it never forgets transformation. Each age leaves behind a fingerprint, even if blurred. If there was ever another civilization before ours, the Earth has already folded it into its memory, compressed beneath the weight of mountains and time. To find it, we must learn to listen to the language of stone, a language written slowly, erased easily, and yet enduring beyond every reset. And as we listen, we begin to understand why our own civilization's story may not end with its disappearance, but with the signature it leaves behind. One day, someone or something may read that signature and wonder who we were, just as we now wonder who, if anyone, came before. In that realization lies both humility and awe, the knowledge that history is not measured by what survives on the surface, but by what endures in the bones of the earth. If there was ever a reset, the proof of it will not be found in myth or legend, but in the strata themselves. The rocks do not lie. They simply wait for us to learn how to hear them. The idea that civilization could have existed before humanity, or that humanity itself once rose and fell in cycles of forgotten epochs, captures the imagination with irresistible force. It tempts us to see the Earth as a stage upon which other intelligent beings once played, their traces erased by time. Yet within the scientific community, such ideas meet resistance not because of conspiracy or arrogance, but because of the rigor demanded by evidence. Science does not accept possibility as proof. It requires data that can be tested, replicated, and verified through independent means. The reset hypothesis, captivating as it is, so far lacks that foundation. The strength of mainstream science lies in its methods of dating and cross-checking. Every piece of the archaeological and geological record must align within a coherent framework, built from multiple independent measurements. Radiocarbon dating measures the decay of carbon-14 in organic material, accurate up to about 50,000 years. Beyond that range, scientists use other isotopes, potassium-argon, uranium-thorium, or samarium-neodymium, each suited to different timescales. Thermoluminescence and optically stimulated luminescence track the last time minerals were exposed to sunlight or heat. Ice cores and sediment layers can be correlated with astronomical cycles, providing precise temporal anchors. When all these techniques converge, they form a timeline that is extraordinarily robust. That timeline shows no gap large enough to accommodate a vanished industrial civilization within the last 100,000 years. The sediments of that period are well studied, and they contain no unexplained chemical markers, no abrupt isotopic shifts that suggest global industry. Even the younger Dryas, the abrupt cooling event around 12,800 years ago, often invoked in alternative theories, leaves a clear natural explanation in meltwater floods and climate instability. There is no evidence of machinery, energy networks, or synthetic materials beyond those we know to have originated in the modern era. Critics of the reset idea point out that extraordinary civilizations should leave extraordinary traces. Humans have transformed the planet on a scale visible from space. Open pit mines, highways, dams, and deforestation visible across continents. If a comparable civilization had existed even 50,000 years ago, remnants of its infrastructure, disturbed strata, anomalous mineral deposits, vast excavation scars, should remain. None have been found. What appear at first to be mysterious formations, such as the Bimini Road in the Bahamas or the Yonaguni Monument off Japan, have been demonstrated to be natural geological structures shaped by erosion and fracturing, not human design. Archaeology too offers a consistent narrative of development. The progression from stone tools to bronze and iron follows a technological logic that leaves no sudden leaps. Each innovation arises from prior experimentation. Agriculture, writing, and metallurgy all show gradual refinement across regions and centuries. Even when ancient cultures exhibit impressive sophistication, such as the precision of Egyptian stonework or the astronomical alignments at Stonehenge, their methods are explicable with the tools and knowledge available at the time. There is no sign of lost high technology, only human ingenuity honed through persistence. One of the most compelling arguments against the reset hypothesis is preservation bias itself. It is true that the Earth erases much of its surface, but it does not erase selectively. If an advanced civilization had existed within the last few 100,000 years, traces of its mining, waste products, or chemical byproducts would persist in subsurface deposits. For example, the burning of fossil fuels leaves distinctive layers of soot and altered carbon isotopes. The smelting of metals leaves slag, a highly durable residue that endures for millennia. Even if cities were destroyed, these byproducts would remain scattered across the globe. The absence of such residues is strong evidence that no such civilization arose. Scientific skepticism is not a closed door, but a discipline of restraint. It prevents the imagination from outrunning the data. When claims of lost civilizations arise, they are tested through this discipline. In 1996, a sensational announcement claimed the discovery of microfossils in a Martian meteorite, suggesting extraterrestrial life. The world was captivated, but further analysis revealed that the structures could be formed by non-biological processes. Similarly, the claim that Göbekli Tepe represented a remnant of an advanced lost culture from before the Ice Age was tempered by evidence showing its construction within the context of late hunter-gatherer society. The pattern of human development remains consistent even when remarkable exceptions are found. Public fascination with lost civilizations often grows where the scientific record is silent. The gaps in history become fertile ground for myth. People crave narratives of greatness and destruction, of forgotten wisdom and rebirth. Such stories fulfill a psychological need to see ourselves as part of a cosmic cycle rather than an isolated moment. But science distinguishes between story and structure. The reset hypothesis may be emotionally compelling, yet until it produces reproducible evidence, it remains speculative. There is also a philosophical dimension to the scientific rejection of the reset idea. To posit an earlier advanced civilization without evidence undermines the very methods that make knowledge cumulative. Science is built upon falsifiability, the capacity to prove or disprove a claim through observation. A theory that relies on absence, on what cannot be found, risks becoming unfalsifiable. If every lack of data can be explained by erasure, then the theory becomes immune to contradiction and, therefore, unscientific. It moves from hypothesis to belief. Still, it would be unfair to say that mainstream science dismisses the idea entirely. The very proposal of the Silurian hypothesis emerged from respected researchers within the scientific establishment. Its purpose was not to assert that a prior civilization existed, but to test whether such a thing could ever be detected. The result of that test was humbling. It showed that if a civilization had existed millions of years ago, the evidence might indeed be undetectable after so much time. But it also showed that within the human timescale, tens of thousands of years, such evidence would still be visible. In that sense, science does not close the door on ancient resets. It simply places them far deeper in time than archaeology can currently reach. The distinction between plausibility and proof is crucial. It is plausible that the Earth, over its billions of years, could have hosted other civilizations. It is plausible that global catastrophes could erase them, but it is another thing to claim that such a reset has occurred within the human story. Until physical evidence supports it, an artifact in an ancient layer, a chemical anomaly of clear artificial origin, mainstream science must hold the line between wonder and reality. This discipline of skepticism is not cynicism. It is the foundation of discovery. Every great revelation in science has come from asking hard questions and demanding solid answers. The burden of proof rests not on curiosity, but on demonstration. Those who propose that history has been reset must meet that burden with the same rigor that defines the sciences they seek to challenge. And yet, even as mainstream science rejects the idea of a forgotten epoch, it acknowledges a truth that echoes the spirit of the hypothesis. Civilizations are fragile. Collapse is not theoretical, it is historical. Empires rise and fall, knowledge fades, and the continuity of progress is easily broken. While a total reset may not have occurred, smaller resets have shaped the world we know. To understand those is to see how thin the line is between order and oblivion. In the next chapter, we turn from speculation about what might have been to the documented collapses that actually were. The Bronze Age, the Maya, the Indus, the countless societies that rose to brilliance and then fell into silence. They are not myths or mysteries. They are lessons in how civilizations die and how humanity begins again from their ashes. If we search for proof that history resets itself, we need not look to lost ages or speculative civilizations. The evidence already lies in our own record. Again and again, complex societies have risen to remarkable heights, only to crumble under the weight of their own systems or the cruelty of nature. These are not total erasures of humanity, but partial resets, moments when the chain of progress snapped and knowledge had to be rediscovered. The collapse of the Bronze Age stands as one of the greatest ruptures in recorded history. Around 1200 years before the Common Era, nearly every major civilization of the Eastern Mediterranean fell within a few decades. The Mycenaeans, the Hittites, the Minoans, and even mighty Egypt suffered devastating decline. The cause remains debated: drought, famine, invasion, or perhaps a combination of all three. Writing systems disappeared. Trade routes that had connected continents vanished. For centuries afterward, the world entered a dark age in which the art of bronze casting, literacy, and monumental building nearly ceased. When Greece re-emerged, it was not as a continuation, but as a rebirth, carrying only fragments of what came before. In Mesoamerica, the story repeated. The classic Maya civilization reached extraordinary levels of astronomical, mathematical, and architectural sophistication. Yet by the 9th century of the Common Era, its cities were abandoned. The reasons again are complex: environmental stress, deforestation, social upheaval, prolonged drought. Knowledge faded. Later cultures inherited ruins they did not build, trying to make sense of the colossal stones of their ancestors. The Indus Valley civilization, once rivaling Egypt and Mesopotamia in urban planning, disappeared around 1900 years before the Common Era. Floods and shifting rivers turned fertile plains into deserts. Without the waterways that sustained their trade, the cities emptied. Writing, standardized weights, and long-distance commerce vanished. When later peoples returned, they built anew, but without the intricate precision of the old. These collapses were regional, not global, yet they show how easily progress unravels. Each was followed by cultural amnesia. Knowledge that seemed permanent was lost. How to read a script, how to temper bronze, how to calculate celestial cycles. In every case, recovery took centuries. The pattern reveals a sobering truth. Continuity is fragile, and civilization, no matter how advanced, is always one disaster away from forgetting itself. Natural events amplify that fragility. A single volcanic eruption can darken the sky for years. The eruption of Tambora in 1815 brought the year without a summer, leading to famine and social unrest. The older eruption of Thera around 1600 years before the Common Era destroyed Minoan cities and sent tsunamis across the Aegean. Earthquakes, epidemics, and climate shifts all act as reset buttons. They do not erase humanity, but they wipe away the scaffolding of stability. These examples ground the reset hypothesis in something tangible. Civilizations need not vanish entirely to prove that collapse is possible. The record shows that even localized disasters can send ripples across continents. A full global reset would require an event magnitudes greater, a catastrophe touching every region, breaking every chain of memory at once. No such event is known in human history, yet the smaller collapses hint at how it could happen. When we walk through ruins like Mycenae or Tikal, we are not merely tourists among stones. We are witnesses to cycles of creation and forgetting. The silence of those cities speaks of lessons unlearned. The reset hypothesis, stripped of its speculative extremes, becomes a reflection of this repeating pattern. History does not always march forward. It stumbles, falls, and begins again. If such partial resets have happened many times, then imagining a complete one is no longer absurd. It is only an extension of a proven rhythm. And so the question deepens. If the Earth itself were to experience a global reset, what would it look like? What signature would it leave for future beings to find? That is where we turn next, to the blueprint of destruction large enough to wipe the slate of civilization clean. A true global reset is not simply the fall of a city or the ruin of an empire. It would mean the collapse of civilization everywhere at once, the disappearance of agriculture, writing, power generation, and communication in every region. To leave no survivors who could rebuild, the event would have to strike the entire planet, overwhelming the adaptability of humankind. We can imagine what such a reset would look like, not from fantasy, but from studying the planet's own history of extinction and upheaval. At its most basic, civilization depends on climate stability. Agriculture needs predictable seasons, rainfall, and temperatures within narrow bounds. A few degrees of global cooling or warming can shatter that balance. The Younger Dryas showed how quickly change can come. If such a shift were amplified tenfold, crop zones would fail, oceans would acidify, and global trade would collapse. Cities would starve and the population would plummet within a generation. A few scattered groups might survive, but the technological infrastructure that supports them, mines, refineries, data networks, would vanish. In a few centuries, the last traces of the industrial age would fade into myth. For a reset to erase every trace, however, it would take more than societal collapse. It would require the kind of force that alters the planet itself. A massive asteroid impact, like the one 66 million years ago, would do it. The initial blast would vaporize continents. Global firestorms would burn forests and cities alike. Dust and sulfur would blot out the sun for years. The biosphere would collapse, followed by a long winter. Afterward, rising carbon dioxide from fires and decay would trigger a heat wave lasting millennia. When life returned, the surface would have been scraped clean. Any trace of human industry would be gone, buried under new sediments. Supervolcanoes pose a similar threat. The eruption of Yellowstone, Toba, or Taupo at their maximum capacity could eject thousands of cubic kilometers of ash into the atmosphere, enough to darken the sky for years and cool the planet by several degrees. Toba's eruption 74,000 years ago may have reduced the global human population to a few thousand individuals. Multiply that scale, and even the memory of civilization could disappear. The surviving population would face an environment stripped of food and sunlight. Generations later, Their descendants might remember only fragments, stories of fire and darkness, of gods who punished the world. Those myths could one day become the origin legends of a new humanity. Nuclear war offers a more human-made path to the same end. If the current global arsenal were detonated, the resulting fires and soot would generate a nuclear winter lasting years, collapsing agriculture and ecosystems. Radiation would poison much of the biosphere. Within a century, nature would reclaim the ruins, but the isotopic signature of uranium and plutonium decay would remain etched in sediments as a thin band of radioactivity. To future geologists, it would resemble the iridium line marking the end of the dinosaurs, an unmistakable sign of self-destruction. Even slower catastrophes can serve as reset mechanisms. A runaway greenhouse effect similar to what transformed Venus could boil oceans and render the planet uninhabitable. Alternatively, a long cooling triggered by volcanic aerosols or disruptions in ocean circulation could lock Earth into an ice age lasting tens of thousands of years. Humanity's delicate network of interdependence, electricity, satellites, medicine and trade, would unravel within years of such disruptions. The survivors would live without memory of what was lost. Within a few centuries, stone tools would again appear, and the age of myth would begin anew. If a global reset occurred, its geological signature would be unmistakable. The stratigraphic record would show a sudden boundary: elevated heavy metals, synthetic compounds, altered carbon ratios, and perhaps a layer of radioactive dust. Above it, the composition of sediments would change: less nitrogen from fertilizers, less carbon soot, fewer microplastics. The record would show a sharp pulse of industrial activity followed by silence. Millions of years later, only a faint chemical scar would remain, marking the brief moment when an intelligent species transformed the planet and then vanished. And yet, we see no such layer before our own. The geological record of the past few million years, though full of ice ages and eruptions, contains no chemical anomaly that cannot be explained naturally. The rhythms of carbon and oxygen, the ratios of metals, and the dust of ancient atmospheres all align with expected cycles. If a previous industrial civilization ever existed, it left no detectable mark. That absence speaks loudly. Still, the thought experiment matters because it teaches humility. We now know what signs we are leaving behind and how little of our story will endure. In 10 million years, the record of humanity will be a single line in rock. To whoever studies it, our age may appear as a blink of heat and carbon, followed by silence. They will wonder, as we do now, whether the world had known others before. A global reset, total and final, is rare, but not impossible. The planet has already endured 5 mass extinctions, each wiping out the majority of life. Each time, evolution began again, filling the void with new forms. Perhaps civilization too follows that rhythm. Perhaps intelligence is not a singular event, but a recurring experiment. If that is true, we are merely the latest attempt in a very long sequence. Whether we face such a reset in the future depends on how we manage the forces we have unleashed: climate change, artificial intelligence, nuclear power, and ecological collapse. The geological record shows that nature resets itself without hesitation. The question is whether we will force the next one ourselves. The planet endures, but civilizations do not. To imagine a global reset is to glimpse our own fragility against the scale of time. It is a warning written in the language of extinction, reminding us that the only way to escape the next erasure is to understand how many have already come before. The idea that history may have been reset before is not only an archaeological curiosity, it is a mirror held to our own moment in time. Whether or not a civilization existed before us, the possibility itself carries meaning. It forces us to question the permanence of progress, the durability of memory, and the fragility of the world we have built. In the silence of the geological record lies a warning that even the mightiest civilizations can vanish so completely that their memory dissolves into myth. Our belief in linear progress, the sense that knowledge accumulates endlessly and that collapse belongs to the past, may be the most dangerous illusion of all. The record of the Earth shows that stability is rare, that every equilibrium eventually breaks. Climate changes, ecosystems collapse, and species disappear. The only constant is transformation. If we imagine ourselves immune to that pattern, we have misunderstood the scale of time. Civilizations are temporary alignments of energy and order. The entropy that claims stars and galaxies will claim us as well, unless we learn to act with awareness of our place within that cosmic rhythm. The fragility of memory is one of the most sobering lessons the reset hypothesis reveals. Every library, every archive, every digital record we create depends on constant maintenance. Without power, without transmission, they decay. Paper burns, plastic warps, magnetic fields fade. If our civilization were to vanish, our collective memory would survive only in stone and metal, and even those would erode. Within 1,000 years, nearly everything would be gone. Within 10,000, the very shape of our cities would blur. In 1,000,000 years, the Earth would remember us only through chemistry. The idea that we could forget entire epochs is no longer implausible, it is almost inevitable. That recognition invites humility. We are not the pinnacle of history, but a chapter within it. Our discoveries, quantum mechanics, relativity, genetics, may seem final, yet they could be rediscovered countless times across eons by others who rise and fall. Each cycle might begin with fire, progress through metallurgy and electricity, and end in self-inflicted ruin. If intelligence arises often, perhaps the universe is filled with civilizations whose traces have vanished into dust, their only legacy the altered chemistry of distant worlds. The silence of the cosmos may not mean we are alone. It may mean that the lifespan of civilizations is shorter than the memory of planets. There is a moral weight to this perspective. If we are indeed the first intelligent species on Earth, we hold a unique responsibility to preserve our knowledge, to ensure that the story of consciousness continues. If we are not the first, then we are inheritors of a task left unfinished by others. Either way, the duty remains the same, to break the cycle of forgetting. That means building systems of memory that can outlast our own fragility, not only in data or archives, but in ethics and design. Our monuments should not celebrate conquest, but resilience. Our technologies should not consume the future, but protect it. The geological record teaches that erasure is the natural state of the universe. To endure requires intention. Even our attempts to preserve knowledge in space, the Voyager Golden Records, the lunar archives, the messages encoded in satellites, are vulnerable. But their existence shows that we are beginning to think in geological time, to imagine communication with beings who may live in the distant future or on distant worlds. Perhaps that is the first step toward breaking the cycle, to see civilization not as a destination, but as a conversation stretching across ages. If history has been reset before, it may be reset again. The real question is not how to prevent change, but how to ensure continuity through it. Knowledge must become more than memory. It must become pattern, encoded in nature itself, capable of surviving the loss of any one generation. That idea, though abstract, carries practical meaning. Every act of preservation, every sustainable decision, every measure taken to stabilize the planet's climate is an act against amnesia. It is our way of writing ourselves into the deep record, of ensuring that if the next dawn comes after darkness, something of us will remain to guide it. When we look at the Earth, we see both ruin and renewal. The same forces that erase also create. Continents collide and form mountains. Forests burn and grow again. If civilization too is part of that rhythm, then our purpose may not be to escape the cycle, but to become conscious of it. To know that time will wash away all things, and still to build, still to create, still to remember. That is what it means to be human. Perhaps no evidence will ever prove that history was reset before, and perhaps none is needed. The power of the idea lies not in confirmation, but in awareness. It reminds us that our achievements are not permanent, that memory must be protected, and that survival is not guaranteed by intelligence alone. We may be the first civilization to ask these questions, or the latest in a chain of forgotten ones. The difference in the end does not matter as much as what we do with the knowledge. Our task is to build a future that will not vanish into the next layer of rock and dust. Because someday, far in the future, when the oceans have shifted and the mountains have turned to sand, someone or something may study the earth and find a thin line of disturbance, a whisper of transformation, a record of warmth and light, followed by silence. They will wonder who we were, what we dreamed, and why we vanished. And perhaps, in that moment, they will understand what we are only beginning to see now, that history is not a ladder but a wheel, and that every dawn is born from the ashes of a forgotten age.